I'm Melanie Jacobson, and we are here at beautiful Mitchell Park Library in Palo Alto. And we're here today for a zero net energy training for residential structures. And I'm joined today by Dr. Peter Pernijad with Development Services at the City of Palo Alto, and Ms. Bronwyn Berry, architect with Passive House, California. We're going to kick off the training with a brief interview to prompt some of the questions that we're going to be going through during the day and throughout the training. So Peter, will you start by framing the context for the residential zero net energy policy goals in Palo Alto?
Thank you, Melanie, and welcome. And I'd like to welcome Bronwyn to the stage today. We're doing a series of these zero net energy talks, and this is the second, and hopefully there'll be more to come. So I'm honored to be here and in front of Barry, and welcome the rest of the people that are about to witness this next in a series of ZNE talks in Palo Alto. Palo Alto has been pressing the REACH code, the energy REACH code in the area of construction for some time. So this should be of no surprise that we're exploring possibilities. So as regards to framing, what we're trying to explore today is what's possible. What does the future hold for zero net energy homes and buildings? What we're trying to do is pick the brains of the experts, understand from a modeling perspective, from a designer's perspective, from a contractor's perspective, how does this work get done? How do we actually design, build, and get these buildings to comply with the rigorous codes that we pass here in Palo Alto? And we've brought some of the brightest minds in the industry to help explore those questions and hopefully ping off of the crowd and see what additional questions they might have that we can dive into. So this is an open book, and we're excited for the opportunity to delve into this, and looking forward to a great interview. So really pleased with the results.
That's great, thank you. And for Bronwyn, kind of shifting gears, how should today's architect address ZNE as a design philosophy?
So a couple things. First of all, I actually want to commend the leadership of the City of Palo Alto, and particularly Dr. Pernijad, for actually hosting this series. Palo Alto has been one on the forefront of net zero energy design, and particularly passive house design here in the Bay Area. So it's kind of fitting that we're here to really share that, and the city is hosting this event. And in terms of how ZNE should really affect our design philosophy, it really is becoming the only thing of maximum importance to really, essentially, this sounds pretty exaggerated, but to the survival of the human species on the planet. So I don't think it can get any more profound than that. Really being able to transform our built environment and our homes that we live in to sustainable structures that will help ensure that we are going to be able to continue living on a habitable planet.
That's great, thank you. And then from a whole design team philosophy, how does a design team revamp its thinking towards producing zero net energy homes?
You know, it really is a team effort. I've repeated this all the time, and the integrated design and construction approach is really what is absolutely necessary to making these buildings work. It's rethinking our whole approach to how we design, and it's really going back to the idea of collaboration and front-loading so many things that we have historically left at the back end of our design process. So it does completely upend the design and construction process in a way that's quite profound and really career changing once you kind of integrate that into your practice.
That's great.
Yeah.
Now for both of you, what would you say to a homeowner who's on the fence about building to ZNE or passive house?
Peter, would you like to start with that one? It's a pretty, it's a tough one to start with.
Well, I would just say that building to the minimum, being a public administrator, building to the minimum is where we draw the line that you can't go beneath. But we expect so much more. And we know that the residents have always risen to that challenge to not just build a code-compliant house, but to build something more, something that is an example to other communities, that can be looked at from across the globe as examples of how to build a home that expands and reaches beyond this generation and into the next. As we're seeing devastating outcomes from hurricanes across the United States, we're seeing that those people that built above code are reaping the benefits and notwithstanding the damage and the devastation that so many people have witnessed. The same can be said for energy efficiency. We're seeing major impacts of climate change, and today we have the opportunity in the midst of redesigning your home to address some of those concerns that are going to be facing us in the future. So it's a great opportunity. Quite honestly, it's a challenge for the people watching this video to strive for more than just the minimum.
So I'll add to that, one of the things that Palo Alto is renowned for is it's a city of innovation, and it's a city of really bright, the brightest minds working on really amazing technological advances in all fields. And so I would highly recommend that we bring that same thinking of innovation and going beyond to the buildings that we actually spend 90% of our time in. And the other part of those buildings is it's the most expensive purchase you will ever make. It's the biggest investment that you will make in your entire lifetime. And to actually think of that as something that you really will not settle for actually the bare minimum for, and you value both yourself and the future generations enough to make that the best possible building you can possibly afford.
That's great. Well, thank you so much, and that concludes our interview session.
My name is Dr. Peter Pernajad. I'm Development Services Director for the City of Palo Alto, and I'm here to welcome you and introduce an all-star cast to do some really deep diving into zero net energy design, modeling, and construction. This is the second in the series, and not the last of the series of trainings that we're going to host on the topic of zero net energy. And Bronwyn has been amazing. She's and I have been talking about the stigma behind zero net energy buildings and residential for some time. And we know that it's challenging. We know it's difficult. We know there's a lot of stigma behind zero net energy design, construction, and modeling compliance with the energy code. But you know what? It's an opportunity to show leadership. It's an opportunity to demonstrate how to get it done. And I'm sure that after today's conversation, you guys are going to have more ideas and possibly more questions on how to get it done. But we brought together with Bronwyn a series of experts in the modeling world to model your home to comply with Title 24 and CBEC software. We have an architect to help understand and talk through the design requirements, and we have probably, in my opinion, one of the hardest and most complicated pieces to this, which is the contractor, the one that needs to actually build it. And I think we can get through some of the stigmas and the preconceived notions about how to build a house that uses as much energy as it produces over the course of the year. As far as the state goes, this is definitely a direction that we're moving into. Whether the state mandates it or not still is yet to be determined, but we're definitely moving towards that. As code cycle goes, every 3 years, our building code goes through a revision. We're going to be revising our code cycle for the 2020 code cycle. So we're probably going to be extending and exceeding the energy code once again, as we have in the last several code cycles, to achieve even more than the Title 24 minimum. And minimum is the operative word. A lot of homes were built to the minimum in Houston, and they suffered excessive damage. And I recently read an article about how, as designers and developers and homeowners, we might want to try to achieve more than just the minimum. And so with that, I welcome you to think of questions and engage our speakers and ask them about what they would like to do. And maybe I'll just take one question if there's...
Well, another question, I was wondering if you could lower the shade so that you have...
Wonderful suggestion. We'll get the shades lowered. And with that, I'd like to introduce Bronwyn, and she'll introduce her cast. And then also in the back, I hope she mentions about all the wonderful publications that she brought to share, which she would be pleased to sign copies of. And photo ops are also available. So with that, let's give Bronwyn a round of applause.
Thank you, everybody, for coming, and thank you, Peter, and the City of Palo Alto for hosting this workshop for all of us today. And I include myself in the learning, the people who are learning here today. It's an ongoing process. So my name is Bronwyn Berry. I'm an architect. I've lived and worked in the Bay Area for 30 years, and all my architectural career has been here. I like to tell people that I'm originally from South Africa because my accent's a little funny, so like at least it gets your minds set, oh, that's why she talks funny. And then to start you off with this idea of mindset change, I like to tell this sneaky little joke that I'm now an American. And so I often introduce myself as an African American. So what we're going to cover today, this is my AIA slide telling you you're going to learn a whole lot of good stuff. And this is the bog standard information, bunch about new tools, effectively working with energy consultants. I'm going to give you a whole slide deck on Palo Alto projects. So looking at what the assemblies are so that you can do this exactly, cut and paste, repeat, looking at exactly how these buildings are already working in your community. And then fundamentals of building science. I've got Brian Rubin here to give you an introduction to the passive house building science fundamentals, which apply universally to all high performance buildings. Then we've got this afternoon a panel of experts. I have a builder, an architect, and an energy modeler that we will do a nice back and forth, and we'll have opportunity for you guys to ask questions. So the structure of today's session, we're going to start out with my little philosophical overview and a look at my own project, so you can kind of get a sense of what's possible, because Peter said you guys are really, there's a pushback. People are scared of this challenge, and I really want to tell you today, actually this is the most exciting, interesting stuff that I have ever had the opportunity to do, and really what I'm going to be focusing on a lot today is the and beyond, because net zero is actually easy. It's the and beyond that starts to get fun and interesting. And then we'll have a break, we'll look at the Z&E buildings in Palo Alto, some energy modeling, our panel, and then we'll close with some resources and next steps, where else you can get more detailed information. So, I mentioned my new ways of thinking. Really, this is part of the fun of this, is just setting aside all your preconceived ideas of what buildings need to look like and how they function, because I've really had so many mind-blowing kind of like aha moments in this process. And I want to start off with this tweet that a colleague and a passive house owner in Santa Cruz put out just last week during that heat storm that we all experienced here. We're still experiencing. It was 101 degrees outside in Santa Cruz. Inside her passive house, you can just barely see the number, 73 degrees, no air conditioning. So what we're really doing with these buildings is basic resilience design. I would recommend the energy component is really what we've been setting our focus on, but the resilience, the comfort, the indoor air quality and the health and durability of these buildings is way more important and interesting than the energy. So think about, looking at your buildings that way. And every single one of my clients has come to me asking for passive house buildings, not because they're energy efficient, but because they deliver comfort, resilience, indoor air quality, and an occupant experience that is above anything else that they've read about or heard about. So keep that in mind. So the other thing that really the end goals we're looking at are stable peak loads, because peak loads, I'll look at that a little bit in a project, are really what the biggest challenge are for renewable energy generation and transitioning our whole grid system to all renewable energy generation. Absolute energy targets. Right now we are still using the CBEC, the Title 24 software. It's always a percentage better than a comparative building, a benchmark building. I will show you what I've been using successfully is the passive house modeling approach. That is an absolute energy target, and it's reliable, and I'll also go into that, which is really what we need. We need a reliable system and modeling software that we can pretty much guarantee if we design it that way, it's actually going to perform that way. And this is what I've come to actually experience in my own projects. I can say that with complete confidence. I didn't believe it at first. The first project, you're always kind of a bit skeptical. You're like, really? So it's actually going to do that? And once you monitor and compare every time a coconut, you're kind of like, wow, this actually works. So you build a whole incredible body of confidence, and if you use that for your clients, it's a fabulous marketing tool. Right now, and in Palo Alto, you guys are actually really lucky. Your utility is already a renewable energy utility. You guys are unique in probably the whole state of California. So you guys already have problem number 3 solved. So I'm going to just do a quick overview of California's reality. This is a study, a report that came out by the International Energy Agency on California's household energy use, because we're looking at residential. The average home in California uses about 18,000 kilowatt hours of energy. So keep that number in mind, 18,000 kilowatt hours, quiz at the end. And the average home is about 1,500 square foot. It's been going up, but in California, average, that's about mid-range. And 60% of our residential buildings in California are single-family homes. So that's huge. It also makes Z&E easier and also harder, because I'll talk about that a little bit more. So what does that mean in PV? Well, if you break that down, it's about a 12 kilowatt PV array, about 45 panels, and that's what your building would look like. So right there, that's just very clear. In order to actually zero buildings out, we're going to have to really reduce our energy consumption drastically. So the minimum required roof area for that is about 780 square foot. So, it's kind of, and then you got fire access at the ridge and at the sides. I don't know if you guys have gone through that process. So you actually can't use all your roof, even you got a really huge shed roof. You still got all sorts of other limitations. You've got penetrations from plumbing, chimneys or dormers, all sorts of other objects on the roof causing problems for your solar array. And ultimately in California, when we're looking at our carbon emissions from buildings, this is a chart that's on the California Air Resources Board website. That's a pretty interesting graphic that I like to refer to. Our total emissions for residential buildings is apparently 5.37% of our full footprint. But the thing about having detached single-family homes is you need cars to get to them. So I typically lump that amount there into that because they are inextricably linked. And you know, you could potentially add a whole bunch of other things into that. Petroleum refining is another big chunk. You need petroleum refining to operate cars. So once you start looking at these, this is a system. You can't really just say residential is only 5% because nothing functions in isolation. So I'm going to go through a few of my own projects just to give you an overview of what I've been doing and how I've been figuring this out. I did a passive house training in 2008 after hearing about it at a presentation in the East Bay with the Green Remodelers Guild. One quick question over here.
Sounds like passive houses and zero net energy houses are being used interchangeably. Are they the same or not?
Yes, yes and no, and we'll cover that in the second presentation.
Okay.
If I could ask if these blinds could be brought down, it's super glary. Maybe standing here is actually a better idea. So this is a house, a new home that I designed and I work in collaboration with my business partner, Alan Gilliland. I'm the architect, Alan is the contractor. We work together as an absolutely integrated design-build team. We have independent businesses, but our approach and our collaboration is really integral from the get-go. Clients came to us and she liked traditional and he liked modern. She wanted a colonial and he said, I'll just go with that. So in California, colonial, fabulous building form, nice simple boxy shape, big problem, no really short overhangs. So what I did, can't really show it, I'll show it in one of the other slides. I call this my mullet colonial. Short in the front, long in the back. So it's all business in the front, party in the back. The overhangs in the rear side of this, luckily for us, this front facade was north facing. I had the perfect opportunity to orient my building directly north-south, really optimize the orientation. And this was the most optimal, simple, best form factor shape I could possibly ask for. So inside, you know, looks like every other home in California. There are no weird gizmos inside it. This is an all-electric building. And the one thing I want to show you is the induction cooktop. Please, please tell your clients, induction cooktops are awesome. Chefs are getting rid of their gas stoves. Top chefs are all saying induction. It's much cooler in the kitchen, it's quicker, it's more effective, you get the heat right where you want, and there's no gassy off-gassing, there's no leaks. It's the most beautiful thing, and every single one of my clients have all come to me and said, oh, we really want the gas burner. We're like, nuh-uh, you get an induction and you'll love it. And every single one of them afterwards has said, we love the induction. Lighting. I have had a fabulous time from in early my career not being able to find any high efficiency locally made fixtures. LEDs are the most amazing thing on the planet right now, and every hipster in Brooklyn and Santa Cruz is making these gorgeous fixtures. They are fabulous lighting. These are one of my local favorite designers, Palo Designs, designed and made in, I think they're designed in San Francisco. They probably may not be made in San Francisco. But it's easy to do beautiful fixtures, all electric appliances, to really bang down your plug loads and your internal uses. So the stats on this project, by the way, those are also, there's a Cerno fixtures, all LED, made in Santa Cruz. So you can get locally made fixtures. I try to spec all my fixtures. Most of them are made in California. So bottom line for this house, it's just under 3,000 square foot total area, detached garage and workshop. So this is the house, north-south. So the back side is a beautiful south-facing roof. I even actually shifted the ridge closer to the front. So I've got two different pitch roofs. I've got a steeper one in the front because it gives me more area for solar at the back. Turns out I actually didn't need all of it, but we'll look at that next. I've got a heat pump hot water heater in a little side closet on the side here, super close to where all the hot water needs are. And my PV array, a 7.5 kilowatt PV array, is putting out 12,767 kilowatt hours. So total way positive compared to consumption. And now I'll just kind of quickly whip through how this compares to code minimum, what my assemblies look like. Super simple. Once you kind of get this, a wall assembly, a roof assembly, a foundation assembly into your repertoire, it's kind of a cut and paste action. We've developed and refined these systems for all our projects. We're on our 8th project that we're building, Alan and I, using a very simple assembly. We always insulate at the roof. It gives us the opportunity to use our attic for all our mechanical vented mechanical equipment and storage. So it keeps the whole envelope really comfortable and makes your HVAC equipment really efficient because it's inside the insulation envelope. So our roof in this is an R46. It didn't have to be quite that insulated, but it's not terribly different to code. Was R38. This was the 2016 code. Walls were nominal. Walls are an actual R28. So I'm using a 2x6 dense packed cellulated filled wall with the plywood sheathing layer, and then I've got a 3-inch layer of rigid mineral wool on the exterior, a product called Roxol. Then I've got my building paper, my weather barrier. Oh, by the way, my sheathing is my air tightness layer. So that's taped and sealed with a stick, a vapor open membrane at the plywood layer. I've got rigid insulation on the exterior. I've got furring strips, and then I've got my siding. So I've got a rain screen exterior. So my wall assembly is about just under 12 inches total, interior sheetrock to exterior siding. My windows, I use triple pane. They're fabulous, and they're cheaper now than you can buy a mid-range, American-made double pane window. So I tell people that, and they look at me like she's pulling my leg. And actually, it's one of the things I've been really pushing hard on for the last, going on 10 years now, trying to get US window manufacturers to make a higher performance window. Because even in the Bay Area, we could get away with a 2-pane window, but the benefits you get from a 3-pane window are incredibly enormous, not only for thermal comfort, but acoustical comfort. So the acoustical comfort is a huge seller. You had a quick question. These ones were actually Intus. These are an unplasticized PVC window with these ones didn't have a film on. I've used that product. I have to say it took me a while to get over the fact that they were PVC, the unplasticized. I'm not typically a fan of those. I have got over that. There are a number of other window manufacturers out here. The latest project I'm doing is a wood frame with an aluminum cladding. There are lots of options. This full project window package was $28,000 for a pretty big house, front door, and a big sliding paddle door system. So incredibly cost effective. And for the performance, the bang for the buck is unbeatable.
What's the STC rating?
Can't remember, but they do have it, and these are NFRC certified as well. So handy.
What was the name of the man?
Intus.
Spell it.
INTUS. You know, I had hoped to put a resources, like a products list together for you, and I literally was a window into my world. I was up till 5 a.m. Putting a permit set together that's due tomorrow. So I didn't get to that. But if you guys are all on the mailing list, I promise to do that for you and mail you some product resources, list of I've got tons of other stuff here. I'm happy to share all my resources with you. So insulated floor slab. This is something not required by code. Easy to do. 4 inches of rigid insulation underneath your floor slab. It turns your floor into feeling like a radiant floor. Keeps your slab, brings your slab up to like ambient room temperature. People will walk into the building, think, oh, you've got radiant heating. No, you don't. You've just got an insulated slab. Great thermal mass, cheap, easy, stays there for the lifetime of the building. You'll never have cold feet, even without the radiant floor. And air tightness. So Brian will cover this. Air tightness, air tightness, air tightness. Think about when you get into your car and you turn your air conditioning on. What do? Roll up the windows. So when we're designing our buildings and we're specifying our mechanical equipment, think about when you roll up your windows. You're doing that to make an actual envelope for your mechanical equipment to function optimally inside. It doesn't work if you've got a leaky envelope. And there's lots of other reasons for air tightness. Okay, so here's my building. On the back side, there's my nice array, my 28 panels. And here's my energy model. I use the passive house planning package. I'll go into that later on. This is in, we did metric on this one. We interchange between metric and IP. There is a inch-pound version. And what's amazing is this is the estimated heating load, and this is my actual measured heating load. And this is the estimated cooling load, and this is my measured cooling load. So 2 things here. Not only is my energy predictive model insanely close, but I want to also point out the fact that even in the Bay Area, and we're in the middle of a heat wave, we're actually still a heating-dominated climate, which means we need more heating than we need cooling. But we actually need both, and as we've all experienced over the last few weeks, we're probably going to need more cooling. Our climate is warming, our climate is changing drastically. So we use a heat pump system that's ducted with our ventilation to provide both heating and cooling in these buildings. So one thing I'm going to touch on, which is probably could be controversial, but it's really the reality that we have to also consider. With net metering, my numbers look awesome. This has got an EUI of 9.5. My PV production, essentially, with that, it covers the house use annually, and it covers an electric vehicle, the charging for an electric vehicle, and I still have a little bit left over. So this is a net plus house because most people don't count the car. But practically speaking, this house still needs a utility, and I really want to go into why. Down below here is my annual energy use and production graph for this house. We monitor all our projects for at least 2 years afterwards, and I'll tell you a little bit more about why. But I want you to look at, so the red is the outside temperature, just comes in the dashboard of the software. The blue is the energy production, my solar production, and the green is my consumption, so the overlay here. So you can see my consumption actually stays relatively stable throughout the year, except for it goes up here. And guess what? This is winter. So, you know, Game of Thrones, winter is coming, right? It happens here too. But my solar production is a seasonal thing. I get tons of it in the summer. I get more than what I need in the summer, but I don't get enough of it in the winter. Does not cover my actual demand. And until we have storage where, you know, battery storage, the Tesla Powerwalls and the Sonnen products, they're awesome. They will cover our daily duck curve peaks where we can save the energy produced during the day and use it at night, which is mostly when we use it. All good, right? We're great for most of the year. We can easily cover everything with on-site battery or utility, you know. But come the end of the, come winter, those batteries actually do not get charged enough to offset our use. So this is where we have to still rely on a utility, and this is where your utility really, ideally what I've been talking to utilities about is start converting that excess summer energy into storable renewable energy. And that's when you can draw it from the grid. So my point really here is net zero is a nice kind of mathematical conceit, but the reality of it is in the winter, until we can store all of that excess renewable energy, we're not really zeroing out, and it's critical for our designs to really reduce our winter heating loads. Because this is a passive house, an insanely efficient project, and most projects actually have a much higher winter peak, which means higher energy use right at the time of year when the utilities typically have to go to fossil fuel generation. So let that sink in. It kind of gets into some tricky waters, but I want you to also think about that when you're thinking about how to design a house. And remember, winter peak loads are the most critical for our renewable energy future. Okay, a couple other quick projects. How am I doing for time? I'm good. All right. A renovation. I want you to also know this is doable for renovations. It's harder on some renovations than others. We had the fabulous opportunity of doing a pretty much a gut remodel on this Sunnyvale, kind of it was a mock Eichler. This house needed everything new. But the bones of the house were great. This had great framing, bones, and it, you know, everything had really been built solidly. We literally took it back to the studs. It needed new plumbing, it needed new electrical, it needed some interior reconfiguration, and we reclad it and we reskinned it, we re-insulated it, new windows, but essentially kept the footprint intact. And to start with, it was, you know, it kind of had run its course. It was past its sell-by date. The inside had these funky spaces that had very bad interior light balance. It was super glary. The windows weren't really like well placed to get nice interior light. And we got it to look like that. So just the quality of light on the interior made a monster difference. But a couple of quick things in here. Ventilation. This was a nice vaulted ceiling, the open beam. So we insulated above on the outside of the roof. It had no wall insulation. It had 1 inch of rigid insulation on the roof deck. It was a a torch down membrane roof with a gravel top. And we are heating and cooling this whole 1,500 square foot house with that one mini split. So my partner Alan devised a really super simple ventilation and distribution system where we actually could leave this exposed. It was actually a pretty tight budget on this project. So it was really cost effective for us to use the wall mounted one rather than the ceiling mounted ones. You can hide those things. But one thing I'm starting to have a lot of fun with is making my HVAC, all my diffusers, part of my design. You can actually really have some fun with diffuser design. All right, thank you. And I'm sorry, I just had one of my latest projects photographed, and I was hoping that the pictures would be ready, but I really kind of went to town and made that, played with that a lot more in my newer design. So these are new things, new design opportunities that I'm figuring out to play with and actually enjoy. This one was a gas cooktop. They had already purchased this Gaggenau, and they had a whole bunch of appliances that they'd been stashing over the years. So we installed their appliances, but we vent this directly to the outside. So indoor air quality, please, please, please vent all your cooktops directly to the outside. Passive House is sort of notorious for wanting to do recirculation cooktop, and in our climate, I would just say get it out, particularly if it's a gas cooktop. You can do a makeup air damper vent at the floor, which we have done here, because you're extracting 1,500 cubic feet a minute of air. You want to make sure you're bringing that fresh air back in to balance your indoor, your pressure balance boundary. Quick thing, a review of the elevations. Really, I modified the windows, added a transom at the front door, removed one of these windows on the south side, and added a few more on the southwest side. It was heavily shaded by redwoods on the south side, so I really didn't have too much trouble with shading on this project. Stats on this: it's just under 2,000 square foot area. No production on this house. Not every house can be a net zero house. And this one literally had huge big redwoods all on the south side, completely shading the roof area. I could not put a solar panel on there. It would just not get enough sun to make it worth it. But my consumption, remember the 18,000 kilowatt hours per building, average California building, about the same, just a little bit more. So what's that? Quarter of that consumption. So this is the other way we can do nearly net zero, because as I say, not every house can be net zero, so we need to have another strategy for what do we do for those projects. Quick run through, you can see our wall assembly. It's 6 inches of rigid, on the top deck. So I had my beams exposed still. This was actually one of our early projects. We did polyiso foam on the outside. Not because I like polyiso foam, but we literally could not get the rigid mineral wool insulation at this time. This was 2013. They hadn't started distributing it out on the West Coast yet. So we skinned it in 4 inches of rigid polyiso, and we filled the existing 2x4 walls with a dense packed cellulose. And then we insulated at the raised floor. These are really difficult details to do. Raised floors in retrofits are really hard to insulate and to air seal. But we actually did pretty well on this one. We got, for a retrofit, we were down to 1.2 air changes per hour on this project. I'm not going to go into the details. This was monitored by Davis Energy Group, and there's a whole study on it. Sunnyvale Marine Climate looked at the cost the cost increases and the benefits, the savings in energy. Since we did this, we've actually managed to reduce our costs for our assemblies. We are getting much smarter and better at designing and building these things more effectively, more efficiently, and products are actually becoming way more available and cheaper. So our windows on that were pretty easy. Going to whip through this too. This is a project designed by my business partner, Alan Gilliland. I just started working with him. I actually was working for a German window company during the recession when all my clients canceled their design contracts. So I spent 3 years learning, digging deep into super high performance windows and telling other architects about what a triple pane window was. I'd never seen one before, I had kind of learned about Passive House either. So it was a fabulous learning experience and opportunity. And I got to sell Alan these German windows in this project and help kind of finish out the project towards the end of the process. And essentially what was mentioned earlier, all about reduce your consumption first. And this is a typical HVAC use or energy use for an existing 3,000 square foot home. This house is 3,000 square foot. And we basically took that down, we shaved 60% of that consumption off by using these same principles of the super insulation, air sealing, better windows, sub-slab insulation, and energy recovery ventilator. So this is what our PV array looks like to zero this out. And it actually includes the gas offset, so additional panels to offset gas. This house did have a gas cooktop, which we've also moved away from. We don't do any gas connections to our houses anymore for multiple reasons, primarily cost. Anytime we actually call PG&E to add a new service line to a house because we have to upgrade, they want 20 grand for the hookup.
What does Palo Alto charge?
I don't know what Palo Alto charged. That was Los Altos. We're just doing a project there, and we said, you can buy, the client, the only thing he wanted gas for was his outdoor barbecue, and we said, you can buy propane for like 100 years for that amount of money. So we don't do gas anymore because it's cheaper not to. So that's a family of 5, 6.2 kilowatt array panels, and this produces 11,100 kilowatt hours of production. And that is actually our monitoring of that project is still ongoing, and that family of 5 is still, with the electric vehicle and the house consumption, still a plus energy home. Some of the interior shots, and you can see there, this is our generation, this is our consumption. The assemblies, pretty much you can see, same kind of assemblies, right? In our region, this is kind of the average roof, wall, floor, window, and slab. Starting to get kind of, you can see the pattern, right? Now this changes per region and slightly modifies depending if it's, North Bay, South Bay, all the way in San Francisco, but very slightly. Thank you. So if we compare these all together by energy use and by floor area, this is your average California home from that IEA study that I referenced right at the beginning of this presentation. So about 18,000 kilowatt hours per year, 15,000 square foot. These are these 3 buildings here. So the Cottle, actually, their energy hogs that family of 5. 3,200, the biggest home, uses a little bit more energy. The Alamo home, a little bit more efficient, about the same size. And the Sunnyvale home, about 3/4 that. So just to give you the perspective, this is kind of what your energy consumption needs to look like in order for us to get anywhere close to being able to zero out our buildings. And as I even pointed to, that idea of zero is sort of a nice mathematical trick, because the zero really has to happen in the winter. But this is really where your utility will have to get involved and start to be able to save your excess summer energy and send it back to you as stored renewables in the winter. I could go deeply into that, but we don't have enough time for that. So wrapping up, again, comfort, comfort, comfort. Your clients don't care if they save $150 a month on energy. If you can tell them that they can live in comfortably in every single room of the house, their daughter won't have mold growing on the side of her bed, and that upstairs room that gets just unlivable in summer and too damn cold to actually use in winter, they can actually use every room that they've paid for in this building. Comfort, comfort. So, just wrapping up my lessons learned for this segment. Everything I learned in school is wrong. Your walls actually lose more energy than your roof. That's a mind bender. See, I got to like, Yep, believe it or not. Why is that? More surface area. Thank you. But we always get told, insulate your roof, insulate your roof. Well, if you have no insulation in your walls. So, monitor your buildings. If there's anything that I would recommend more than any other measure, if you can monitor every single one of your designs, starting now, you will learn more from that than anything else. The third, build a team. None of this happens in isolation. I could not do any of this on my own. I need a really great builder. I need somebody who really knows how to do great HVAC and an energy modeler. Now, luckily, I happen to be an energy modeler and an architect, and my business partner is a great HVAC designer and a builder. So we kind of have the team, a two-person team that kind of covers all those bases. But if you don't, find what you're missing, partner, and work together. It's really rewarding. It's just the same challenges as every other contractor-architect relationship where you're like, no, I want it to look like that. And he's like, no, but it costs too much to do that. So you'll have those same fights, but when you're collaborating and working towards the same end goal, your outcomes will be really fabulous. Learn energy modeling, learn energy modeling. Even if you don't end up doing every aspect of the energy model, you need the feedback loop of what really matters and what doesn't. And you need to do that at schematic design, not at the end of your contract documents, when it's way too late to do anything to improve your building. Front load it. Your HVAC system, got to be designed at schematic design. If you're basically designing these nice, weird rooms that no ducts can get to, and then your structural engineer comes and sticks a nice big beam that no ducts can get through, you've created a really uncomfortable room in the house. So get familiar with HVAC, work with your HVAC guy if you're not the HVAC person. Understand where everything is going. All your systems are going to be installed right before you even present to your client. Have a schematic HVAC plan done. Work with your guy that you always work with. Keep it simple. Keep it simple. It's so easy to add dormers and bump outs and gables and, multi-slope roofs. Cheap design. It's a cheap design solution. It's much harder to do a simple design. Keep sloughing off the excess, the superfluous. It just makes everything much more complicated, more expensive, harder to heat and cool, harder to insulate, harder to air seal. And this is a topic that's going to take a long time for us to really integrate, because I know as a practicing architect, we're also fighting a lot of design guidelines that are imposed on us by cities, and I've had that really tough conversation in a lot of places. We're going to have to really reevaluate what our designs, what's the idea of a really a good design and what our buildings, our cities need to, the aesthetic that's going to be driving our future building philosophy. And get comfortable with mistakes. We all make them. Architects have a lot of liability, but the beautiful thing about this approach and doing beyond code minimum design is you're already baking in a lot of actual resilience to your design. You're covering your butt, and the monitoring gives us the most amazing insurance policy that our buildings are functioning and that everything's working. And we get to see what's not working before our clients do. So we can call them and say, hey, guess what? This system isn't actually functioning or what are you doing? What are you doing with the stove? So it's, there's a real benefit to actually understanding what you're doing and catching not only your mistakes, but your subcontractors' mistakes, and actually oftentimes manufacturers' mistakes, because stuff doesn't always work the way it says so on the box. And the only way you catch it is if you're monitoring it. I'm whipping through those because I think I'm out of my time and I want Brian to have his say. Windows matter. Shading. California, we have lots of this sun. We have tons of light. You can see I've actually blocked some of it. We have too much. And we are greedy with windows. You can get fabulous light in a house without monster amount of windows. They are leaky, poor performance, glary, and cold in winter. Don't get greedy with windows. Air sealing, we'll go into that more. Roof design, simple. Drive your own energy model. This seems like the luxury thing to do, is be chauffeur driven by your energy modeler. But if anybody likes to know how this analogy maybe is not the best thing, but when you drive your own vehicle, when you drive your own energy model, you get the immediate feedback loop, what's working. And as designers, architects, builders, we have to understand what's working. So, thank you. I'm going to let Brian come up next.
Thank you. Can everybody hear me okay? Just a quick show of hands. Who is a designer or architect in here? Anybody? Okay. Contractor or sub? Okay. Homeowners? Anybody? Anybody renting? Okay. Anyone not raise their hand? You can raise your hand now. Okay. So as Bronwyn said, I'm on the board of Passive House California. I lived in Colorado for a number of years. I studied environmental design at the University at Boulder. Learned a lot, but as Bronwyn said, you don't learn enough. I'm originally from New York. I went back to New York and got a degree in construction management and have sort of been bringing those two together ever since. I think it's the team that Bronwyn mentioned is critical, and having the understanding of how a building gets put together is really important when you're actually designing it. And if you can front-load the design with high performance concepts in your mind and with the team, then you're much better off as you get further along. So Bronwyn's projects are amazing, but I'm going to break it down very simple, try to give you guys an understanding of what this is on a very basic level. So here we go, introduction to Passive House. Before I go there, Passive House California is part of the organization, the NAPHN. That's the North American Passive House Network. We have regional affiliates in New York, in Maine, and Vermont, and there's more and more growing every year. If you need more information, not just from us, if you have clients out of state, there's a huge network of resources out there. We are also, you guys are at the prime time to see this. We have a conference coming up next month, the Passive House, the North American Passive House Network Conference. It's an annual conference, and we are going to go into depth on all of this stuff here. So if we don't answer your question today, if you guys want to come to the conference, you'll learn as much as you possibly can. We have all the experts in the industry coming for this. It applies to homeowners, it applies to contractors, it applies to energy modelers. So I would encourage you guys to take a look at this if you don't get enough information today. Okay, so CO2 emissions. We have, a lot of people think cars are the big CO2 emitters, but in reality, buildings are pretty big here. And this isn't just running the buildings, this is also sourcing all the materials. We're extracting, wood and cement and metals and minerals. All of that stuff has embodied energy that takes a lot of time and effort and energy to extract and then ship to the project sites and then erected and built, and then there's some waste. And so all of these things have energy that's built into it. And once the building is actually built, which takes a tremendous amount of energy, we're running the building. Here I'm feeling pretty cool right now after being outside for a while. There's a lot of energy, a lot of air conditioning being pumped into this room right now that takes up, this 44%, which is almost half of industry and transportation. So keep that in mind. Jerry Brown, he came out and said the state of the new nation must be aggressive about setting goals, such as having zero net energy residential buildings by 2020 and commercial buildings by 2030. That's a very aggressive statement. We're almost at 2018 right now, so that's 2 years away. 2020, 100% zero net energy, 2030 in commercial. And then we also have 50% for retrofits. Like Bronwyn showed you, that's what this house would be, the way construction is today. So, Passive House 101, this is the way it's been in the 19th century. We have this great big fireplace, it heats the room, everybody's happy. In the 20th century, things got a little more complicated. We've got all sorts of high-tech systems, furnaces, boilers, we've got things pushing air. The house has gotten very complex because we've gotten away from, efficient buildings. We can do HVAC and other things. Here we are today, 21st century. Look at how comfortable this guy is. The sun is coming in, simplified systems, much more manageable. I'm about to play you guys a 90-second video that explains what Passive House 101 is. There's a lot of information in there. Try not to blink because you'll miss something. And I will come back to this and we'll go in depth into each of these items in a minute. So here we go.
Passive House explained in 90 seconds. Does your house have a heater in the basement or maybe a fireplace? Probably also a central air conditioner or maybe a window unit. Did you ever wonder if it was necessary? In 1991, a physicist in Austria, Dr. Feist, built the first passive house. Here's what he did. 1. Proper insulation. It's just like wearing the right winter jacket. It also doesn't need a heater. 2. No air leakages. There should be no holes, small or large, to let hot air out of the house. 3. No thermal bridges. A thermal bridge is like a road for heating energy in which warmth can travel right through your walls. As a matter of fact, most of our houses have thermal highways in our walls where heat can easily travel to the outside. Plus, the house needs proper windows, most of the time with triple pane glass. It needs to be oriented properly so the sun can heat it in the winter and shade is provided in the summer. And it uses an HRV, a device that provides the inside with fresh air without letting the heat out. Add all these things up, and it turns out your house doesn't need a heater or air conditioner. So where does the heat come from? A passive house needs 90% less energy, and that can easily be supplied by your body heat, the sun, your appliances, light bulbs, and even your TV. This saves you a lot of money on your heating bill and helps preserve the environment.
Okay, so there you have it. 5 major principles in 90 seconds. I'll try to break it down a little slower for you guys. A lot of people think passive house is only for single-family homes. They think airtight buildings have bad air quality. I've heard a lot of people say you can't open the windows with a passive house, it just doesn't work. They're too blocky and ugly. There's a lot of things. These are all false, and I'll show you exactly why. As Bronwyn mentioned, passive house is the path to net zero. Here, we have these incredibly efficient homes that use very little energy. And if you can put that energy in a source of renewable energy, then we're all winning here. The big picture here is clients that have lots of money, they don't care about how much their heating bill costs. It really comes down to using less energy, being more comfortable, being healthier and more resilient, and I'll explain what this all means. Here, this shows the kilowatt hours per meter squared annually. Traditional buildings are at about 180. Really high energy or high performance buildings are at 66 or so. Passive houses are way down here based on what Bronwyn was showing earlier. Almost 90% reduction in heating, cooling, and total energy usage, almost at about 75% reduction. Comfort, this is a big one. If anyone has ever been in a passive house, it is just extremely comfortable. Here we have kids in New York City sitting right next to the window. There's snow outside. It doesn't even faze them. These are triple pane windows. It's just comfortable. When you're in a passive house, everything is uniform. The temperature, there's no temperature differential between indoor and outdoor or within the space. Also with these triple pane windows is the noise mitigation. I've had a lot of clients who are psyched about triple pane windows. They close them. It's like closing a submarine chamber. You can't even hear the outside noise. Some clients are more excited about the noise than they are about how high performance they are. Being healthier. With all these systems in effect, we can reduce how much HVAC equipment we need and the size of them. Here we have a much smaller HVAC system. Inside air is completely exchanged with the outside air. There's no stale air, there's no mold or moisture problems, and we'll talk about that a little bit more. The homes are generally healthier, cleaner, respiratory illnesses are down, dust, asthma, they basically go away if you're building a passive house. Resilience. This is a chart showing the indoor temperature and the outdoor temperature in New York in 2014. I happened to be living there during this Arctic vortex that they were talking about. It was incredibly cold. You couldn't go outside without covering every square inch of your skin. Here, the house, as the temperature plummeted, the house maintained the same, more or less the same temperature with no heat. Here, they turned on the heat just a little bit just to bump it up, but basically this house maintained its indoor temperature all week, 10 days, with turning on the heat once, and it was amazing. I also happened to live in New York City when Hurricane Sandy came and hit and wiped out power for a while. There were passive house buildings there with no power, even no HVAC equipment cycling, and they maintained their indoor air temperature for the whole week, which was phenomenal. Again, the path to net zero buildings and more. There's more and more options to bringing in renewable energy when your energy demand is so small. So keep that in mind as you're reducing the energy loads. What other types of energy can you bring in to offset that? Here are the 5 key principles that the video just discussed. Up here, number 1, climate-specific installation. I'll talk about what that means. Thermal bridge-free construction. That's something that is going to take a little time to understand. Contractors have been building a certain way for a number of years, and it's hard to break old habits. That's what I'm struggling with every day. High performance windows, we'll talk about that a little bit more. Air tightness, we'll go into depth on that, and high efficiency heat recovery ventilation. So if you take all these 5 things, and they're very basic things, this isn't high tech stuff, you can get close to building a passive house, if not a passive house. So here we go, insulation. Continuous insulation, not just insulation, but continuous on all surfaces is a key factor. If you put on an oven mitt and you go to grab a hot pan on the stove, if you have a little hole ripped in that right in the palm, you grab that, you're going to feel that. If you have a sound glove all the way, you grab that, it's continuous insulation on your hand, you're fine. This is something that can be an issue that or something that should be highlighted, continuous insulation. Every 16 inches on center, you have framing in a traditional home. Every 16 inches on center, you have no insulation because that's where the wood is. So continuous, like Bronwyn pointed out on some of her projects, she had insulation on the exterior, meaning that it covered the entire surface. Also temperature, climate-specific insulation is another concept. You wouldn't want to go camping this weekend in your winter sleeping bag. You would be sweating all night. So you want to pick insulation that is climate-specific and that plays into what your energy model is showing. Thermal bridges. These are potential. A thermal bridge can be a cantilever that sticks way out. You have a steel beam or a wood beam that goes outside and it comes directly inside. That's the most obvious one. These can cause condensation. There's all sorts of discomfort thermally, and an energy loss. So what we like to do is we go around the building when we're designing in the early stages is to identify every connection, every point where there's going to be a wall to roof or a wall to floor, or and identify what is happening at these locations. Here's an example of a therm model showing what your floor and wall assembly could be. Here you can see the purple and the blue is the colder climates. This is the exterior here, and the cold is just staying on the very outside. All the warm is coming down here and it's staying inside. So you look at every connection in the building when you start planning this out. Integrated windows and doors. Bronwyn mentioned triple pane is the highest quality right now. And it's not just about the window as well, it's also about the installation. Here we have, this is a window frame certificate. This basically says that this frame has undergone a bunch of testing. It conforms to these standards. It is it's a passive house rated window, and there's a lot of windows out there that have this. So make sure when you're designing that you look for this. Make sure you're getting exactly what you're looking for. Here's another therm model showing the different relationships to where the window is actually sitting. You can have this far left one shows the window close to the exterior of the wall assembly. Here we have the window in the middle of the assembly, and here we have the window towards the inside of the assembly. These all have different functions. It's the exact same window, but an energy modeler will be able to calculate which of these is the most optimal way to set the window. This far right one is tricky because you're not going to get much solar gain coming in here. So if you need to get the sun in your building for heat, this may not be the answer. Plus, that you're getting some pinching over here. This looks pretty optimal right now in this sort of diagram. Continuity, thermal continuity and comfort. This goes back to the kids sitting in the window. It's 6 degrees outside. You typically have, let's say, 59 degrees on the inside. On the opposite side of your room, at 68, you're going to feel that temperature difference. Even though it's very subtle, that's going to make you feel uncomfortable. It's sort of an unconscious feeling. In a passive house with triple glazing, you can get a more ambient, more uniform temperature within the space. Your floors, your walls, your countertops, everything should have more or less the same temperature, and that just creates comfort. You're not walking through a house where your feet are cold and your head is warm, and there's all these different sort of temperature ratios. Here in California, we were talking about shading. These are all factors that you want to take on when you're designing your project. How much sun do you get? How much sun do you want to keep out? We can also go a little further along when you're doing the modeling. I think Bronwyn's going to talk about energy modeling later. You can calculate how far away your shading device is. If it's a tree, how tall it is, where that sun comes in, and how big and how tall these windows are, and where they are in relation to your surroundings and your envelope. This is all building science, and this is all stuff that needs to be considered when you're doing your home. Air tightness, continuous air tightness. This seems like a pretty simple concept. If you have a balloon and you put a pin in it, it's going to pop, all the air is going to come out. It doesn't matter if the hole is really, 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 really small or really big, it's still going to leak. Same thing for your bathtub. As soon as you open up that drain, all that water is going out. So you can put, I've heard clients say, I want the best insulation possible. that's great, but you're actually going to end up wasting some money if you're not airtight. You're still going to get, leaks, drafts coming in. Airtightness is really, really key. And for those skeptics that say airtightness, you're going to develop a sick building. Talk about that later. Here, this lady is using a blower door, and for those that don't know what this is, you close off everything in your home. You hook up this blower here to this door. You have a computer that sends all sorts of testing stuff to it, and you pressurize your building. And you can either put positive pressure on it, you can put negative pressure on it. Oops, I don't know why this is doing this, but here's a red line test, similar to how we identified the thermal bridges earlier. I don't know where my dot went, but if you can trace a line around every single connection in your section, you should be able to identify the weak points and where your airtightness may happen. Here's what I was talking about before. Positive pressure means you're bringing air into the building and you try to find where those air gaps are, typically around windows and things. Negative pressure, you exhaust the air out and you try to find where the air is coming in. A common issue with something to consider when you are doing doing a blower door test is a lot of times your building is very tight, right? And the areas here where the makeup air is coming in or finding its way into the building is through crawl spaces, it's through attics, it's through weak points in your air barrier. And those areas are not the healthiest air to be breathing in. You want to bring air in through your controlled HVAC equipment that's filtered, it's fresh and clean, and so forth. So this is a big concept. Airtightness is really key. Here we go. Why do we build airtight? Condensation in the construction. Condensation goes back to early, schooling. If it's cold outside and it's warm inside, somewhere between the outside and inside is going to be the dew point, and that's where you're going to have condensation. And so the goal is to get that condensation to happen outside of the building, not inside your wall cavity. That's where you get mold and all sorts of other problems. Drafts, obviously. If anybody's been in a really old brownstone with a double hung window, you know the air is just coming right in. It doesn't matter. Preventing cold floors, preventing air pollution, securing the sound insulation of building components, securing operation and effectiveness of the ventilation system, and so on. Here we have ventilation. So now we have this super airtight building. Nothing's happening. It's almost like a vacuum. We introduce what's called a high efficiency heat recovery ventilator. This is your HVAC equipment. And with the building being so tight now and so efficient, your HVAC can go from these big, big rooms down to these smaller units. They use way less energy. You can localize it, you can have distribution. Low flow rates is a lot of really good ways to control the HVAC equipment. You're not going to have this humongous duct coming through here because the room is going to be more efficient in general. In terms of ducting as well, passive house, a lot of people consider passive cooling as another sort of key term, but we try to bring fresh air into the bedrooms. One concept is reducing how long our ducts are. If we do that, we increase efficiency. That's one way. If you're forcing air all the way down a long corridor, then you're going to be losing energy all along that way. So we try to keep everything really, really short. So here, we supply air into the bedrooms. We can leave some gaps under the doors to have it actively sort of pass through into hallways. And we have bathrooms where we can extract the air. We want to bring moisture, we want to bring stale air. Kitchens and bathrooms are typically where you want to extract everything out. So if you supply to the bedrooms and you provide space, you can actively or passively have the air flow through your entire building. And Passive House measures how many air changes per hour you are actually bringing all the air out of the building and bringing all the air back in the building. So there's nothing about staleness. You're bringing in the air in a very controlled environment. It's not coming up through the crawl space where there's mold and nasty stuff. Let's see. Okay. Here is a very, very basic schematic on what an HRV or an ERV is. That's an energy recovery ventilator. So here, this is the inside on this side, and we're extracting the warm air. Like right now, it's warm. We extract the air outside, and at the same time, we're bringing cool, let's say this is a cool scenario, bring cool air inside, and at this point here, the air is not actually mixing together, it's not getting contaminated, but they're passing past each other. There's a series of filters and things. This little box over here allows the cool air to be preheated as it comes in with the warm air that's coming out. So you're starting, here's your heater coming in, you're starting at a much higher temperature, it's more efficient, seems pretty simple, but, and these are really high performance units, they come in all different sizes and shapes. At that point, we've gone through all these different things, the 5 principles. Here we have optimizing heat gains. People, we give off a tremendous amount of heat. If everybody in the room started doing jumping jacks, I'm sure the temperature would rise in here quite a bit. Appliances and equipment, these all give off, heat. Daylight, bring light in, same thing. Lighting, other things, TVs, lots of things bring on heat. So here, at this point, we are near passive house. We've got the enclosure is optimized. We've got the heat, the optimized heat gains, and the ventilation. And so now, if we have all these things organized, we can figure out the next step to get into passive house. And that has to do with heating and cooling. If you've done all of this, you now know that you only need a very incremental amount of heat to warm it in the winter or to cool it in the summer. This can be done with air handling units. It can be done with heat pumps. And here's sort of a different approach to different heating and cooling. We have recirculating air, there's radiant, although this may set us over the heat demand, there's hydronic. These are heat pumps for heating and cooling. These are becoming more and more popular because you can bring these lines, these refrigerant lines and things into smaller spaces and get far, back to the harder places to get to. Yes.
So if you use those, you still need that system to exchange the air, right?
Exactly. So you have this unit on the outside. This unit sort of represents one of the many options that are out there. And then, these would work in concert together.
No, I know those go together, but when you had that chart earlier where you showed the air being pulled in.
Yes,
so you
exactly.
Circulate, so you still need a circulation.
Yes, exactly. You'd still want some sort of heat recovery ventilator. The question was, would you need another system? This would just be the boost to get you to be where you want to be, heating and cooling wise. You probably wouldn't need this most of the year, but you still want that HRV or ERV. This is a ducted mini split. This is basically the same. There we go. This is basically the same as this unit, but now there's ducted options as well. I did a couple of these in a New York City apartment where the ceilings were really high. You can squeeze all that in because they didn't like the look of these things on the wall. But, finally, we can introduce smart systems. Solar thermal is really great for heating water, domestic hot water. There's obviously PV, there's wind turbines, there's all sorts of things you can do to help this cause. This is an image of some pipe fittings. This is, we have all these different systems. Continuous insulation was one of the topics. Here we're just showing that, every little thing can be insulated just to make sure that it's continuous on the inside and outside. There is all sorts of tools at your resource right now. Many years ago, you'd be having to try to find all this information, but there's certified professionals. I'm a professional, certified, Bronwyn is. There's a whole network. If you go on to Passive House California website, passivehousecal.org, you'll see we have all sorts of consultants and designers listed. There's modeling software. There's a million different kinds of components now. There's assemblies, there's windows, there's products. People are putting all their information out there. It's much more readily available. And then there's Passipedia. The resources are starting to become endless at this point. There's also a bunch of certifiers now. It's great to build your home to Passive House standards, but it's also really great to certify it and to show others that you're doing this. The more that we get the information out there, the more this is going to catch on, and the more other clients are going to want to do this as well. So certifying, there's a handful of certifiers out there, and the list is growing. Here are some projects. This is a pedal house tour that we did last year. Passive houses don't need to look like a spaceship. It can look like anything, any other typical house. This is a home in Palo Alto, so is this. They look very different, but they have very high performance. Same thing for this one. This is a mixed-use building, so you're not limited by design aesthetics. A passive house can be adapted to any sort of style. I might need to lean on Bronwyn for what these buildings are, but I think this one is an apartment in hotel in China.
Yep.
So here we have,
Super humid climate. I think it was Hangzhou, the city. Not sure. China is actually really taking on passive house with a vengeance because they realize they can't keep building coal-fired power plants. So they have been building demonstration projects of this scale and larger all around in all the different provinces of China. We have a delegation of 20 academics and industry representatives coming to the conference and also to share with us what they're doing in China and also to trade and learn what we're doing over here. So it's pretty exciting. Globally, this is happening.
this one is an office building.
Yeah, you want me to? I moved
Sure.
these slides very well, and actually a lot of these are my own images. So this is a bank building that's completed.
We're gonna hold that mic, use it.
Great, thank you. Can you hear me now? Sorry, just forgetting that I didn't have my mic on. This is a bank tower in Vienna. Bank bought the old OPEC oil buildings in Vienna and renovated the two older buildings next door and built this infill tower in between. It's a super sexy building. It's completed. It looks like it shouldn't be a passive house because it's an old glass facade, which normally would be not a passive house. But it's actually just a rain screen facade, and you can see on the inside there's some of the opaque insulated walls behind that glass facade. This is the renovated brownstone in New York, so it can be applied to historic buildings. This one. This is a courthouse, also in Vienna, that I visited with a prison next door. It's more like a holding tank prison for processing in the courthouses next door, but it's an incredibly modern design. Lots of high security issues that they had to deal with, but really awesome innovation happening, and all sorts of really cool special rotating doors that were designed for this building. So lots of products. So Research Science Center outside of in Minnesota. It's part of the University of Chicago Research Center. It's a field science station designed by an architect in Maine. That's also a passive house. I don't actually know what this building is. Let's skip it. Dormitories. Okay.
Yeah.
Oh, it's a dormitory building also. Sorry. And this is probably going to be the next, the tallest passive house building in the world. It's currently just going through the entitlement process. It's in New York. There's a race on for the tallest passive house building in the world, and currently the winner is the Cornell Tech dormitories in New York on Roosevelt Island. Coming up close, just ready for completion, is an apartment tower building in Bilbao, Spain. The architect is coming to our conference in Oakland in October. And there's another tower going up in Vancouver.
There's also another office building going up in Frankfurt that will probably surpass this one. So really, this is not just residential low rise. This is skyscraper level, and there are hospitals, university research centers, all sorts of building typologies like applying the same methodology. It's an incredibly exciting field to be in, and incredible innovation happening in this methodology.
Thanks. So, last slide. This is just the beginning. We have tons of information for you guys. If this wasn't enough, please look at coming to the conference in October. It's in a few weeks now, so there's still a chance to buy tickets. NAPHN Network. We're also part of Passive House California, a localized group, and we put on events, all over the state. We happen to be heavy in the Bay Area, but we have representation now down in LA, and we're trying to go down into San Diego and other areas. So I encourage you guys to come out and join us again. And we only have a minute or two for questions, but if you have any, we can take some. Sure.
Just one question. What do you guys see as the barrier to the acceleration of the adoption of this methodology?
Fear of failure and having that not actually being confident enough to try it.
Question. Can you repeat the question?
Sorry. So the question was,
What's the single largest barrier
the single largest barrier to
the adoption
to this
of
movement. Yeah.
because the reason I asked that is I was involved in a project in Canada back in the 70s called the Advanced Homes. This came really on the heels of the Gutter 2000 disaster because they tried to do it, and that was, talk about a stillbirth, that was a stillbirth. And a lot of the methodologies that are actually done in this process were actually done in these houses. I don't know if you're familiar with it, but there was an advanced home built in every province on its state in Canada. And they're still there, and they're still being monitored in a couple of cases. I think the Surrey one in BC is still being monitored. They've reached similar levels of performance, but of course, back in those days, they didn't have the technology that we have today.
I think one thing that we're up against in New York and other climates where it's like really extreme, here we're in California where people say, I leave my windows open all year round, why do I need to insulate or air seal or anything? And there's science behind doing this, and that's like some of our biggest opposition to the climate here, and I think it's part of it, and fear, I was saying.
Apathy and fear would be my answer.
Well, I don't think it's apathy, I think it's cost in some instances, because you have to be able to convince people there's a cost of information. But that's not my question. My question was very interested in the positioning of the windows, because from a design professional point of view, it's the detailing of how we're going to maintain both the airtight and the thermal bridge break when we're putting windows in what in the details that Bronwyn showed us were interior layer, exterior layer. I would like to see a series of details posted for waterproofing and trapping, making sure we're not trapping water where we don't want them. They're venting appropriately at the right place, condensation that's coming on the outside.
I recommend you go and look at any older building in California. All of them install their windows in the middle of the wall, not to the outside. Look at how we currently do that. And I will give you a link for a resource for some fabulous window installation details. It is a critical detail. You want to install your window in the middle of your insulation layer, where it becomes the most thermally optimized and continuous thermally for your building envelope. I could go, I've done tons of super geeky presentations about that. Windows is my kind of specialist that I'm really interested in, but I will give you resources and links for real great details.
Yeah, Bronwyn has developed her own custom proprietary detail installations, so maybe we'll share those. But it's a good question, and now our research is out there.
We are going to go have a quick break because I think everybody's about ready to move around.
Okay, question. Is there
there any outreach to building code, bill planners and people in government?
Absolutely. Bronwyn, this is perfect for you.
Lots of it. Ongoing, and it has been for a long time. But really what we found is until you have enough buildings built on the ground working, everybody sort of looks at you again, and then you sort of, and you know, myself too, I was skeptical. You need some proof of concept, and the book that you all were, that you were all welcome to take a copy of. This is 32 passive house buildings in California. There are more than that. There's coming up to about 100 of them built on the ground. This works here, and it's amazingly effective and cost effective too. And the cost is always, everybody kind of freaks out at the cost, but then I ask them, oh, so what refrigerator did you put in your house? I got Sub-Zero. So you've got that right there will pay for the increased installation cost in your whole house and drive the cost of your project down for the entire lifetime of the building. So we have the money, we just are not allocating it in the right place. So with that, I'm going to get everybody to have a break. We've got some refreshments at the back there. Get up and stretch, and then come back and we'll get back into some more nitty-gritty details. Thank you.
So, 7 projects right here in Palo Alto. I called them the 3 gables, the 3 larger buildings, and the tiny house. So I won't really go through this, but it is kind of interesting to get a national context. We're obviously right here in California, one of the most densely populated regions of the whole country. And then right here in the heart of Silicon Valley. So just climate context is very important. And this is the location of these projects. This is the 7 projects we did the bike tour of in 2015, and we repeated it again. It was great fun. It was like the Peloton riding around Palo Alto. It was really, really an awesome site visit tour. More climate data, just to get an idea of heating degree days, Fahrenheit day per year. This is the passive house way of calculating it. Might be slightly different. They use a different degree baseline comparison. But San Francisco, 2,493 Fahrenheit day per year. San Jose, 2006, so obviously a lot hotter, less heating degree days. And Palo Alto, we're somewhere right here in the middle. Not quite the same, a little bit warmer than San Francisco, but cooler than San Jose. Just an overview of these projects. We have some of the architects here and contractors. I'll point them out. This was one of the very first passive house projects in Palo Alto. In fact, I think it was the very first. Sven Thiessen's Project Green Home. It's on, is it Stanford Street? It's right there on the title. Arkentilt Architects, David Arkin is right there. David, you want to raise your hand? He's going to be on our expert panel, so he can probably tell you more about this house. Really lovely house. Passive house consultant was Dan Johnson, and the builder was Quantum Builders, and I was working for them at the time and was involved in the window spec for this particular house. The second house on this cluster, right next street over, Oxford Street. This is a really interesting building. It looks like a single-family home, but it has a full basement, and it's really a multi-use kind of community space for a really fabulous group of people that do education and community living. There are 7 dormitories at the back side of the house with bunk bed kind of sleeping lofts. Big community kitchen and dining room in the front. Lots of multi-use spaces in the basement of this house. It's a pretty big house, but it's more than a house. It's a whole bunch of different things. Luke Morton, Pearl Reniker and Alan Gilliland, who will be here as well, were involved in this project. Really interesting mechanical system design in that project. This is a really lovely home. It was an old holiday cottage for a San Francisco family built in the early 1900s. All redwood interior that the architect and the owner really wanted to maintain the redwood interior paneling. So this was really renovated from the exterior and insulated on the outside, and the design and the character of the house were really beautifully maintained. Scott Shell of EHDD, the architect, and Graham Irwin of Essential Habitat was the passive house consultant. But really, you can see it's a really lovely project just up the road in I think is it Portola Valley, just not too far away. This is a new build on Poe Street. A very typical Palo Alto looking house. They did a fantastic job with shading on this house. I went there on the tour and I just thought, yay, they got it. They made sure you've got windows, but they're well shaded because you do not need that heat gain, especially once you super insulate and you air seal. Fergus Garber Young are the architects. Pearl Reniker was the passive house consultant, and Pete Moffat was the contractor. And this was the Mighty House by our very own Brian Rubin and his lovely wife, Sienna. They have been building this in their backyard and was on display at our conference at the Palo Alto Community Building. What was the name of that other building? I forget the name. Where we had our conference in 2015. Lucy Stern, thank you. So Brian and his lovely wife and their gorgeous daughter, where is she? She's somewhere there. If you ever get the pleasure of meeting her, their kids, they're amazing. Have been building this tiny house using this whole passive house approach. So really, and then the last one is the Bernstein residence. Stuart Bernstein's the owner, and Fergus Garber Young, the architect. And Smith Hyder Construction. This is a beautiful house built using SIPS panels in a super accelerated time frame. And then the last one is an office building. This is the first passive house office building built in California by Clarum Homes. They're a home builder developer, super green, eco-friendly. It's on Olive Street. EID Architects, who actually also leases part of the office space from Clarum Homes, was the designer, and Clarum Homes was the builder. So when I put all these buildings together, I got the PHPP energy model from all of these consultants, shared them, and I just started to stack them up next to each other to start to see what is a passive house building? Is there a vernacular performance design for Palo Alto passive houses? And what I came up with was some remarkable alignment in an incredibly wide variety of size, shape, style of buildings. And so I think this is a really fascinating thing to look at when you can put them all together in the same sort of spreadsheet. Our roof assemblies for almost all of these, including the Mighty House, were within a very tight range between, what's this, R value of just over like R32. The Stanford Street project had a higher R value of R45, but pretty close proximity for a roof assembly. Same with the exterior walls. I found this fascinating. So the R value of the walls for all of these buildings was around R25. The other one, this is between, what's this? It's about R22 to R27 maximum. And just so you know, this is actual, not nominal. So you know how lumber is actually, it says it's a 2x4, but it's only 3.5 inches. Well, your insulation and your walls is kind of the same thing. You can put an R19 bat into your wall, and your wall is not an R19 insulation value because it has studs, which are much lower insulation. So your actual insulation value of your wall will be about an R13 or 14, depending on how much wood you have in your wall. So these are actual insulation values rather than nominal, just to be very clear. Floor slab. Some are raised floor and others are slab. And this was where there was, this was the only one that really had, well, there were a couple of sort of little more divergence in the assemblies than these two, the roof and the wall. And can anybody tell me why you think the Mighty House had more floor insulation? There we go. So it's not connected to the ground, right? It's isolated. It's essentially floating. So if you, essentially the same concept would apply if you had a full cantilevered second floor that was floating out above open space. You would have to really super insulate that floor because it's exposed to ambient temperature rather than to ground temperature.
Which of those are raised floor and which of them are slab?
You know, that's a good question, and I can't actually remember, but maybe we can kind of figure it out. Oxford Street, that was the multifamily. That's actually a slab on grade. It's a basement. Stanford Street is also slab on grade. Field Chirello is the raised floor. It's the redwood building. Poe Street, anybody remember if Poe Street, it also has a basement, so I'm assuming it also is slab on grade. It's a 2-story up and 1-story down. Clarum Offices is a slab on grade. Mighty House is the tiny house, raised floor. And Bernstein also has a basement. So pretty much all of them are slab, except for the Mighty House. And then your window U values, again, incredibly consistent, but very important to show. Check out my window R values compared to my wall R values. So anytime you're sticking one of those in one of this, you're making about the total, insulation value. You're cutting it by about, 7/8. You're really dropping. Windows are fabulous. I love them. I'm a big fan of windows, but you got to use them sparingly, because look what they do. Look how poorly. And these are triple pane windows, by the way. Triple pane windows, okay? So if you're doing double pane windows, you're probably less than half. The size factor. This was also a fascinating kind of breakdown of putting these all next to each other, because the size of them varied greatly. This was the mixed-use building on Oxford Street. It was large. It's just over 5,000 square foot. The two sort of normal, modest size, around 2,000. Field Chirello was the cottage, and the Stanford Street project, the Arkansas Hill building, was just over 2,000 square foot. Poe Street and Clarum went back. Those were getting in the large size. The tiny house, can't get any smaller than that. And then the Bernstein residence was also large, over 5,000 square foot. So really, the size didn't make a huge difference to the wall assemblies, the roof assemblies, the window. And then when we look at the certification metrics for passive house and we stack them up next to each other, it did make a big difference in your annual heating demand, because more square foot requires more heat to keep comfortable. So you can kind of see the Mighty House doesn't need much heat to stay warm. It's tiny. Bodies would warm that up in no time, right? Especially Vivia and Brian. Sienna have a very awesome, active daughter, the best kind. The field Chiarello actually has quite a high heating demand number, and the certification cutoff target for passive house is either heating demand or heating load. And what I was kind of fascinated by this was a bunch of other passive house consultants that had done the modeling on these projects. So I got a window into how other people use the energy modeling tool, which was fascinating because you don't normally get, it's kind of like looking into the guts of somebody else's, home. You don't always get that view in. And I was fascinated to see how many of these projects actually use the heating load as their certification target, which is really a smart way to go. I've come to be a big fan of this metric. So it didn't pass on the heating demand, but it passed on the heating load, and that's the target that they used. But for the Mighty House, it's really hard to get such a small building down under the 10 watts per meter squared passive house heating load target, but you can get it under the heating demand target, no problem. So what this is telling me is flexibility. You got options. Passive house is known for being incredibly rigorous, and people look at it as being very circumscribed and saying, there's a ja, nein. The joke is it's German origin, and they say ja or nein, and it's nothing in between. But within that parameter, lots of options that you can explore, and you've got some flexibility to play with, which I found pretty interesting to see. Primary energy, so this is the total amount of energy used by your building, including your heating, your cooling, your plug loads, your hot water heating, your lighting, the full enchilada. This is keeping the full total way down, so we can use renewable energy as our primary source. And all of them, the 120 kilowatt hours per meter squared per year was the old cutoff point. Pretty much all of them went kind of right up to the edge, which tells me particularly, well, even the small one, the bigger ones, Clarum, Poe, and Bernstein actually went under, which is awesome. And air tightness. So air tightness, everybody, when you first do your first passive house, the thing everybody freaks out about is like, oh my God, am I going to make my air tightness? Because your blower door test is basically the tell-all. You either pass that or you fail it, and it's the biggest stressor. I always kind of joke that when you buy the passive house planning package, it should be shipped with a box of Xanax, because that gets stressful. But I will tell you over and over again, the first project is the hardest, and every other one after that gets easier and easier. And so these were some of the very first projects in California trying to get to this 0.6 air changes per hour blower door. They all made it except for Field Chiarello, but actually Field Chiarello made it because for retrofits, it's more flexible. You can get to 1. So every single one of them made it, but they just scraped by. And I can tell you, my projects now, we're getting to 0.3 and 0.2 on a regular basis. It's N50, natural pressure at 50 pascals. So there's all sorts of geeky terminology about air tightness and how to do the blower door testing and volume calculations. It gets nice and nerdy. Quick questions here.
Yes, in none of your projects you use hot water heating system, green hot water.
They all have hot water systems. My own projects, we use all heat pump hot water heating systems. We used to use solar hot water, but we found that actually it's much more efficient and cost effective to use the heat pump hot water heaters because there's less to go wrong with them, and it's the coefficient of performance of the heat pump process is so good that, and they're just so reliable. But real deal breaker for solar hot water is the backup storage tank that you have to have with them. We don't need that with our heat pump hot water tanks. So it's. Is that what you were talking about? Hot water heating?
Actually, solar water heating.
Solar water heating, yeah, which is what I'm saying. It's like we've costed them out, and we actually found that our heat pump hot water heaters are more cost effective and also less complicated, and we don't need the backup tank, which is a space savings thing. So that's a hot and heavy debate. I don't want to get too deep into it because it's actually not my field of expertise, but that's kind of what I can tell you about hot water.
Palo Alto is giving rebates if you're replacing an existing gas water heater. If you change to the heat exchange water
The
heater,
heat pump.
you get a big enough discount so that you
Yeah.
can think twice.
Well, it's also just, we did a heat pump hot water heater workshop in this very room a few months ago. Summary of this little exploration into Palo Alto's passive house cluster. All the assemblies, if you kind of design your houses, to have about that level, what was it, an R23 wall assembly, an R36 to 42 roof assembly, an R14 floor slab insulation level, no thermal bridges, airtight, and triple pane windows. Guess what you got? A really, really efficient house that's basically a passive house in Palo Alto. That's super easy to offset with PV to net zero it out, and actually be a plus energy because you can then charge your electric vehicle. So those are just some passive house geeky things, 2 certified by their heat load criteria. But really what this really demonstrated unequivocally to me is tons and tons of flexibility within the constraints of this design challenge. There was everything from a retrofit to a small house to a SIPS panel project to a regular stick frame, and everything in between. ICF walls. The Oxford Street, yes, had ICFs. So, any different building methodology and materials can be applied, and they can all just meet the benchmark target performance levels. So, that's it for...
Don't skip that last line. You said none of these houses has an attached garage.
Sorry, thank you.
That's a problem, isn't it?
You know what? It just makes things so much easier. All right? So that's good that you pointed that out. Every time I have an opportunity to design a detached garage, it makes all your junctions easier, your insulation easier, your energy modeling easier, and your indoor air quality assurance much easier. Our cars, we spend an insane amount of money to house our cars, and it's the one thing that as soon as you buy it off the parking lot, it devalues. So I'm a big fan of bicycles. But people are electric vehicles. Palo Alto is the hub of the electric vehicle movement. But really, detached garages make designing high performance buildings cheaper, easier, healthier. All those other things. So thank you for pointing that out. It was a really strong point. So thank you everybody who shared their data with me to be able to put this presentation together. I am hoping to actually follow this up with the utility bills for all these projects. It's just been a function, to really see like, okay, so we got all the modeling data. Now how do these really perform? And so I'm hoping the next year or two I'll be able to find some spare time to get that one done. So, all right, so we're going to move on. I've got one quick other presentation about energy modeling tools before we go to our panel of experts. See, where is my... So this is where the rubber hits the road. It's all well and good coming to a workshop and learning about how other people do this, but the idea is I want you guys to be able to go back to your offices and do this yourselves. And if I can do it, I can tell you every single one of you can do it. I was a solid A- student in college, all right? And when I goofed off, it was a B+. So, it doesn't take any rocket science genius for it. So, the target where we're really trying to get to is all renewable energy future. I don't need to give you the lecture about that or any slides of polar bears stuck on ice floes. So, what we're trying to do is design buildings that can directly use renewable energy right at the source, if preferable. Any excess can be stored on site or by the utility with short-term storage. And the other part of the energy equation for that winter load that we can't meet on site or with our local storage gets stored into winter long-term storage. And where I'm hoping that utilities finally figure this out. This is an awesome business model. So however they're going to store it, that's their job. The mom and pops and our own, we're not going to be able to do that on our own properties. So that's kind of the main target of where we're going. This just shows how Passive House is really primarily focused on your energy and your comfort. We've talked a lot about that today. Brian went through all the building science fundamentals that underpin Passive House, and it's really focused very primarily on that. And I wanted to show the other standards. It plays very well with them because your Passive House tools and methodology can help you meet all these other wonderful certification standards that also cover other aspects that Passive House does not focus on. So Passive House doesn't tell you what materials you need to use. It doesn't tell you what water, how you have to retain your water on site, all those other things. So I just want to make that clear. And the Passive House standard, just to repeat, because we didn't really cover this in much detail, but just to give you what the framework of it is. It's this absolute energy benchmark target for projects to meet. And the question that came up earlier was, how does Passive House differ from net zero? And it's a subtle difference. Net zero doesn't tell you how efficient your building needs to be. It just tells you have to have enough solar to zero out your use. Passive House tells you exactly how efficient your building has to be. It says you have to be less than 15 kilowatt hours per meter squared or 4.75 kBTU hours per square feet, either heating or cooling, or 3.2 BTUs per hour per square foot heat load. You got options, but those are the efficiency targets. Your house has to be less than that, and the air tightness has to be less than 0.6, and your total energy use has to be less than, and I'm getting to that because it's switched to be a sliding scale that has credit for renewable. And then there's some adjustments for climates with humidity to take into account latent loads. There's some factors. The cooling number only adjusts slightly in climates that have a lot of humidity to deal with. And so that total primary, the full enchilada of energy that you can use gets divvied up. There's three levels now of efficiency. There's the classic that has super low efficiency. So that retrofit I did in Sunnyvale that had no roof area for solar, there's my classic. Bingo, I got an option. It's got a target, and this is where it differs from zero. because it gives you an option for houses that cannot get to zero, but it has the benchmark. Then it says, okay, if you add solar to your house, you can go up to, you can level up, you can go to plus. Or if you want to add more insulation and lower your demand, you can also get to plus. Because it's this sliding scale, you can either improve, it's a function of energy supply from renewable resources over the final energy demand at the building. And you can see how you can move up classic, plus, and premium. And premium is for those people that really want to mega, add mega renewables. There's also a function, option for having renewables off-site. You don't have to have the renewables on the building. You can purchase credits at a wind farm that are tied to the title and the ownership of the property. Or you can do solar credits. It's complicated. It's only really an option for the premium level. But it allows more equitable accounting for urban, dense, multifamily buildings. Because single-family buildings getting to zero is pretty easy if you have the solar access, but for dense multifamily urban buildings, which really are much more efficient overall and economical for many other reasons, allows them to also be credited and get the same equal treatment. So,
What's PER?
primary energy renewables. Thank you for asking. So this is the framework that has been redeveloped to give credit to what it does is it incentivizes fuel switching, and there's a whole other presentation I could do on that. It gets really pretty granular, but it gives more credit to all electric buildings than what used to be. Gas used to get a lot more credit than electric. Electric was penalized under the old framework because for renewable energy to become a reality, we have to really switch to all electric buildings. Gas doesn't get terribly penalized, but it doesn't get incentivized in the same way as it used to be.
Just to follow up on that question.
Yes.
Are we going to see those changes ripple into Title 24?
I've been visiting with all of those folks, and they're still getting their head around what this means. And so I think it's going to take a while. I've been having those conversations. Well, I'll be diplomatic and say no comment. They are well-meaning and trying to do the right thing. I think there are lots of pushbacks, and really showing them a viable framework that's working and that actually provides solutions is part of what we've been doing as an organization for a number of years. We're just starting to get their attention. So it's kind of interesting. So there are the three certification levels: the classic, the plus, and the premium. And we went over what those look like. Tools, energy modeling tool. So you can go and take a 5-day training to become a certified passive house consultant or designer, which really is a much more in-depth training about all the principles that Brian presented on earlier. Really understanding the physics behind and getting deep into the window installation details and the thermal bridges and the air sealing details and the mechanical systems design, the ventilation system duct layout. It's the most geeky fun you'll have since you left college, and it'll wreck your head in the best kind of way. It's one of the best trainings that I've done. It does take an investment of your time and some money. We are trying to get utilities to subsidize that training, because really this is where all of us need to be able to really integrate this into our practices and make it make it just the new normal. The Passive House Planning Package is the energy modeling software. I had never done any energy modeling until I took the training, and then I learned how to use this software. It's a spreadsheet. Everybody kind of has an idea of how spreadsheets work. It's a big spreadsheet, but it's with a big fat manual, and but it really gives you it's the tool that you need to get your feedback on how your buildings really need to be designed, and what you're doing that's working and worth doing and maybe trying more of, and what really doesn't make a difference. So that was the key thing for me. This is the energy balance. This is the fundamental equation that forms the foundation of Passive House. It's balancing your losses with your gains and coming to this beautiful equilibrium. And really, so your ventilation, you lose energy in your ventilation system, and you lose energy through your assemblies. So that's transmission losses. So that's loss of transmission and ventilation. Those are your losses. Subtracted from, and this is a factor, n factor, from your gains. And you get gains from solar. And I can't see the number, but I'm seeing a board raised. 15. Okay, thank you. I'm good. Lots of internal gains. Bodies, equipment, appliances, they all get calculated. And then what's the balance left is what your heating system has to provide. So there you have the essential Passive House equation, and you'll learn how to, just so you don't get freaked out, nobody asks you to do these, but they explain the whole full, the math behind it, which I think is super important for us to grasp and understand, because each of these then has these sub-equations. How do the transmission losses get calculated? How do your losses through your windows get calculated? How your walls get calculated? How are your walls actually, what's the real insulation value of them, and how you can do it. And then, by the way, the energy model, you just input the values and it calculates it for you. So that's the beauty of a spreadsheet. It makes it simpler, and you don't have to do all the math. But the model, basically, you do need to understand the equations and the rationale behind the energy model. So this is the spreadsheet where you start. Basic modeling, you start with inputting what your surface areas are. You input what kind of windows you have, whether they're triple pane or quadruple pane, and how much frame, what type of frame they are. You input what your ventilation system is, and then it's these are, you input the R values into your areas, so you can tell how good your assemblies are, and what your ground connection is, whether you're a floating floor or connected to ground. You start with the climate data. Sorry, I missed that. That's key. Before you do anything, you tell the software where your building is on the planet, because that makes a very big difference to what your levels of insulation have to be. And essentially, bottom line is then you start to get these numbers, and they tell you, ooh, so if you do this design with this amount of windows and your assemblies are this, your heating demand is going to be this. And then it says, ja or nein. And when it says 9, you go back to the beginning and you go, oops, okay, let's fix that. And then you start playing with it. You add more insulation, or you toggle the window design, you shift things, you make them smaller, you make them better. But you got options, right? And then you get to ja. Once you get to ja there, then you look at the summer requirements for cooling and shading. And then you get your mechanical systems, you input all those. And once all of those, your primary energy numbers are met, it says, yes, this is a Passive House building. And you can get certified if you want to. It's also optional, but having somebody else look over your shoulder and help you with your modeling process and verify that you're doing the model correctly is enormously valuable. and worth doing once at least. So, other tools available. The Passive House Institute brought this out a few years ago, and it keeps getting better and better. It's a SketchUp plugin where you can draw your architects. I love this because I can do this too. Much easier than having to calculate areas. You basically just draw it in SketchUp in the plugin. You click on the wall and you assign it an insulation value, and your windows the same. And then you export all this. It calculates. It tells you what your it only really gives you heating load, and it's just a sort of a helpful tool. It doesn't give you the final, but it really helps for visualizing and for client illustration purposes. But it's a really good, quick start to helping you with the energy model. And then you export this final thing back into the spreadsheet to complete the mechanical system design, because SketchUp hasn't quite got to where you can do mechanical system design in it. But it's a really great visual modeling tool. It helps with analyzing shading of trees, neighboring buildings. I've seen some really elaborate versions of this, of whole cities being modeled with the tall building using this plugin, and it's super helpful for complex projects. There's now an online guide to certification on the Passive House website, the passivehouse.com is the International Passive House Institute's website, with this great certification guide that's just come out that really outlines all the details. They have an online certification platform now where you work with a certifier and just upload your documents as you go through the certification process, and you could both get up to the dashboard and see, yes, have you completed that step? Have you submitted those documents? They're trying to simplify the certification process and really make it easier. And the guide has sample drawings, what you really need for certification, how to illustrate your site plan, showing what are the shading elements around, and then how to illustrate your elevations, showing how you came to your area calculations. It's just part of the verification process that goes in certification. And then there's closeout documents at the end of your process and your building. This is also ongoing. Passive House certification only happens after the building is complete and your blower door test has been passed. It's not something that gets issued ahead of the time before your building is done. And what happens is it's also iterative, because as everybody who's worked on a project here knows, the drawings are never exactly what gets built. Stuff happens in the field, and products don't get made available, or might not be in stock, or the contractor will find a cheaper product. So it's ongoing. Your spreadsheet gets constantly updated to actually match what gets built, and at the end of the process, the house, the owner, the builder, whoever is in charge of the process, gets to sign the declaration that yes, this energy model reflects exactly what was built on the site, and then you get your plaque issued, and you get to have a certified Passive House building. So before we get into a panel, really remind you that I would not have thought this was possible until I did it. And the more I do it, the more there's no way I will ever go back to building conventional buildings. It gets integrated into every design aspect and construction aspect. And our next panel, we get to actually talk to other people that have been doing this, and hear their experience of how what's working for them, and how it's really fundamentally changed how they practice. So, quick question from you.
Yes. Were you going to talk about how you monitor the home's performance?
The guy who is perfect to answer that has just walked in the room, my business partner, Alan, and he's going to be on the panel. So save that question. because monitoring is a beautiful one to add to our panel. So I am going to invite our panelists up. I'm really pleased to welcome three lovely gentlemen that I'm pleased to also be able to call friends of mine. I've known David for many years, and Alan I worked with since 2011 and got to know him through our Passive House community. And Steve, I've had the pleasure of getting to know over the last few years, who does all the Title 24 calculations and HERS ratings for all the projects that I've been working on with Alan. So I'm going to let you guys give your own introductions and focus on the Passive House and Net Zero projects that you have designed so that people get a sense of where you've worked and what you've done. So David, if you'd like to start.
Great. Be happy to. Thank you, Bronwyn. I've had you on panels that I've hosted, so this is payback. No, I'm very pleased to be here. I was thinking about, how I was introduced first to architecture, which was Ed Masria's Passive Solar House book that my parents gave me when I was in the 8th grade. And then came here to California and worked on the Solar Living Center up in Hopland, which was one of the first high-performing passive solar projects, but certainly nowhere near Passive House certified. My wife, Annie Tilt, and I then started our own practice, and one of our first projects was also straw bale, like the Real Goods building, up in Nevada, a very extreme climate, and a net zero energy home 20 years ago. So it's fun to see the evolution of the Passive House with the projects that we've done. Gratefully, you showed the Stanford Street, Sven and Kate Thiessen's home, which is Passive House certified, LEED Platinum, first urine separating toilet in North America, all sorts of things that we were able to get in there. And I think I was pleased to see the mention of the carbon footprint of our energy use, and one of our focuses in our practice is really the embodied carbon in the building materials themselves. And you mentioned doing a project with cellulose insulation and a wrap of mineral wool. We had that in the Stanford project. We're now actually wrapping, doing the thermal break with cork insulation. So really trying to look at lower carbon footprint because it's today's carbon that's going to make the difference, as well as the energy carbon used. So, so I don't get it wrong. Build with carbon, mostly plants, not too big.
That's really good.
Thank you, David. Alan, if you'd like to give us a...
I would, but first I'm going to ask a question. I'd like to know who's in the audience. Are there any other architects in the audience?
Yeah.
Okay, all right, some architects. How about builders? A couple of builders. And homeowners? So mostly homeowners. Pretty good mix. Okay. You know who I'm addressing. I'm Alan Kittleland, and I have the pleasure of working with Bronwyn. We have a design-build practice called One Sky Homes. And as Bronwyn mentioned, we've been working together for several years. I started green building back about the turn of the century and discovered in 2007, I think it was, I read something, it was Governor Schwarzenegger introduced the so-called Global Solutions Warming Act, Assembly Bill 32. And I read about it, and that was the one that now, fast forward, we're a couple of years from 2020, as part of that legislation was mandating for California in the energy code that all residential buildings would be net zero by 2020, and following that in 2030, commercial buildings. And the idea of producing what you use, just a basic, simple concept, just struck me. This is just so simple and profound. So I started at that time my zero energy journey, and fast forward, we've done about six projects now, and our latest projects are all zero carbon, So there's absolutely no fossil fuel burning in the projects. And this again is in accord with the climate action plans of the state and the broader world to move toward electrification. And the little questions here that Ron wanted me to address about that, because I mean, 5 minutes isn't very long.
Oh, you have more than 5 minutes, but we're coming back to the other questions.
I
We're doing
understand.
round one, and then we'll
Okay.
we'll give you more.
You're going to come back to these other questions on the list?
Yep.
Okay, all right.
Yeah.
All right. Well,
So just today,
so-
this is just the introduction.
This is just the intro, okay. Well, I'm the builder side and she's the design. The only thing I would say is that in a design build practice, I don't know how anyone else would approach building a high performance building without the integration of the design and the build process. It's just so important. There's the devil's in the details, and having a continuous process allows us to manage and be successful. So I think that integrative design or design build, whatever term you want to use, has been really important to our success.
And just to background, Alan really got to build the first net zero new home that the California Energy Commission actually gave him a commendation and recognized in San Jose. And there's a great video that he came up with of heating the house with a hairdryer. So it's really it's a 3,200 square foot house, and it's on the One Sky Homes website. So Steve, if you would like to give us your curriculum vitae, just the abbreviated Reader's Digest version.
Yeah, short form resume. Hi, I'm Steve Mann. I have a company called Home Energy Services up in Berkeley. Like these guys, I have been designing and building stuff, but I'm here as the energy consultant geek, I think is my role here, the modeling person. I've been building stuff for 30 years, and I have a copy of Ed Masria's book, and I've done solar training at Hopland, so we've got that in common. I test their houses. I do the commissioning on their houses, both the passive house related stuff and also the HERS stuff, because that's the California Energy Code side of things. It has really nothing to do with passive house. A little bit of overlap, but it's sort of separate. It's the blower door testing and those kinds of things, testing the ducts for leakage, stuff like that. I'd say I've only been doing this stuff for about 12 or 13 years, although I've been building as an owner builder for 30. And I started out looking at green stuff, sustainable stuff, LEED, Energy Star, all of those things back in about 2005. And then about 2007, I encountered Passive House, and like Bronwyn says, it's really like a virus. Once you get exposed to this stuff, you really can't see doing anything but this. It's really that, to my mind, it's like so pervasive and so persuasive. It's crazy not to build buildings this way, absolutely. So I got bit by that bug, and here we are 10 years later. I wear a lot of different hats. I do passive house design and modeling for my own projects. I built my first passive house I finished it about 18 months ago. I'm getting ready to break ground on the second one in about 3 weeks. And it's a much bigger project, so it's really kind of interesting and stressful, but very exciting too. I do green certifications, LEED certifications, passive house certifications in their various forms. So I kind of like I'm not a builder except for me. I'm not an architect except for me, but I do all this like the housekeeping for all these guys. So I work with builders, I work with architects, I work with homeowners. Anybody who wants to build a good high performance home that hopefully incorporates as much passive house stuff as they're willing to let me convince them to get in the house, I'm there. I love doing this stuff, it's great. So.
Thanks, Steve. And Steve built a backyard cottage in Berkeley, in his house in Berkeley as a passive house. And that was awesome. We got to tour it. Our community he invited us in to have a look at it.
It's a little bigger than Brian's tiny house, but not much.
So the next question I wanted to ask these experts, and then after the couple of questions you see, I've got them up on the screen here, and then I would like to open the questions up to you guys, because these are some of the premier architects, builder, energy modeler that are really focusing on this stuff here in the Bay Area. So David, if you'd like to give us your kind of take on what's been the most challenging aspect of doing net zero design and kind of lessons learned or your mistakes? Because I think, you know, we have a culture where nobody likes to admit that they make mistakes, but those are what you learn the most from, and if you can share them with others to prevent them having to make the same mistakes, I think that's a really valuable contribution that we can all make, a gift that we can give each other. So if you're willing to fess up.
I don't think we have enough time to cover all the mistakes that I've made in my life.
Building one's
well,
own.
You know, I was focused on the net zero aspect, which is really what we're targeting here, and thinking of a couple of our projects that we've done specifically off-grid, where the renewable energy on site is being counted on to provide all of the electricity that powers that home throughout the year, which means we have, you know, that winter dip in the curve that you mentioned that we have to fill with on-site production. And how often we underestimate how much energy people use in their homes. And I think a lot of it comes from, you know, designers and solar people who really geek out over saving every little watt, and they just assume that everybody else does that as well. But as you pointed out, you know, going over, generating more, having enough to power an electric car, we have these devices where we can control and buffer the demand side of the homes in a way that allows us to produce more. And there were disincentives in net metering that you didn't want to generate any more than you were using, and those are falling away, and they're realizing that if you have a big enough rooftop to generate more than you use, great. We'll take that power and feed our grid and serve those other homes. Let's see, other surprises worth mentioning. Well, I think it's how often I'm surprised by how people start a design project without gathering the important information. And that is, what is your, the window of solar gain that you have available to you? What are the appropriate passive solar response strategies? You know, what works in this place? And it varies from one corner of the Bay Area to the other vastly. It's one of the exciting things about being an architect in California is there's no one answer in every place. It's different everywhere. So getting to know that for your particular place is I think one of the key pieces to creating the passive house. Yeah, I'll leave it at that, hear what the others say, and we'll keep it going around.
Okay.
Great. Thanks.
So I came up with 3 things in my journey, which becomes an awful lot of learning every day. First is building physics and science. Second is, as David mentioned, really energy loads, understanding what energy you're using, what's being consumed in a building. And then third, the practical aspects of construction, materials and techniques and so forth. So the first one, building science and physics. What happens in a passive house or any whatever standard you want to use, when we expect more of our building envelope, when we're trying to very carefully control the thermal energy flows, we're really asking an awful lot, an unnatural thing of a building enclosure, okay? Because most importantly, with thermal energy comes moisture, right? So when we manage heat, we're also managing moisture. And moisture is what makes buildings fail. So we make buildings tighter, we add more insulation. Okay, great, we're controlling the heat. You know, we're either keeping it out in the summer or we're keeping it in the winter. But at the same time, we're also having an impact on moisture, most importantly, in its vapor state. And so I would say to anyone who's a builder, you're wandering into a world where you must understand the physics and the science of your building, or you're going to end up in a whole lot of trouble. So I had a case, we're supposed to fess up on mistakes. Perfect example, the first building that I did, we had a detail of a conditioned crawl space. And so I enclosed the crawl space, and somewhere along in the process, it's a long time ago, to remember, but I got kind of worried. I was kind of worried about, well, what's going on in that crawl space, because there isn't any ventilation and so forth. So I went down, and lo and behold, I looked up, and there on the bottom of the floor, I started to see a little sign of mold. And I realized, of course, what was happening was that the concrete was curing, okay, and giving off an awful lot of water vapor. And the building at that point, the crawl space was not conditioned yet, right, because we were still in construction, so I didn't have a lot of moving air. I had the crawl space hatch open and so forth. So the first lesson was, and because I caught it quickly, because I was kind of paranoid and skittish, so I started seeing, so immediately high pressure washing and bleaching, and it was very minor, so we were able to do that. We put in dehydrators and so forth. We caught it. But the point is, there are dozens of these kinds of conditions where you can get in trouble if you trap moisture. And this is where you see this is where all the lawsuits come from and so forth. So I would say building physics and science are something that are foreign to our building culture, but as we move into high performance building, they need to be central to it. Every architect, every builder must understand the basics of building physics and science, or we will have lots of building failures. Second, energy loads. David, I won't spend too much time. How much do you spend on, hot water and laundry? How much do you spend on heating and cooling? How much do you spend on plug loads for, food storage and preparation, etc.? All of these are things that most people just don't know. If I ask anyone in here, so how much how much energy do you spend on hot water and laundry? You couldn't tell me. So if you're going to produce what you use, you have to know what you use. And so we monitor every project, and the only way we learned all this is by monitoring and looking at loads and being surprised by, oh wow, that takes a lot more than necessary, and so on and so forth. So you have to understand the same thing besides the building physics and science. You need to understand energy. And thirdly, so when you go out in the field and you're actually building these things, what materials you use. Again, with respect to moisture, I'd say, as contractors, we are legally responsible for a building. If it fails, we are sued, and if it's a big failure, we're likely to be out of business. So we tend to be conservative and understand and use practices that we can count on. Well, this is all new. All the building assemblies and materials are all new. So you're wandering into an area where there's much higher risk, and you must understand, again, the building physics and the science. You have to understand the materials and how they affect what you're doing, and you need to make sure that you're constantly trying to keep things simple. We live in a complicated world, and a lot of these assemblies and these new things, and the way that many architects, I know David's not the case, but they're highly articulated buildings, and they're super complicated, and they have complicated roofs and structures and so on and so forth. That's all antithetical to a durable, high-performing building that doesn't have failure issues. So learning about keeping it simple, and what works and what doesn't and so forth is it's just basic experience.
Thanks. And just before you start, Steve, one of our audience members had some monitoring questions, so we'll come back to you, Alan, afterwards. So I just want to let them know that monitoring is really key, and we'll elaborate on that next.
Okay.
So Steve, thank you.
Quick story, not about one of my mistakes. I'll get to that in a minute. There's a well-known builder. This is a client of mine. Well-known builder who built a house in the Bay Area that was a quote-unquote passive house. They built this about 5 years ago. They did not understand the physics, the building science, the moisture issues, anything else. The house was, I believe they've pretty much torn it apart and rebuilt it from scratch. Multiple lawsuits, sick house syndrome, mold infections, just all kinds of unbelievable horror story. So I absolutely totally agree with what Alan says. Absolutely, if you're going to build a high-performance house, you really have to know what you're doing. My mistakes, geez.
like everybody, so many. I'd say this kind of echoes some things that have been said. Details. You want to detail things before you build the house. It's really dumb to start building a house with sketchy plans and say, oh, well, we'll decide that once we get there. Been there, done that? Bad idea, really bad idea. My latest project, we've got 9 or 10 pages of architectural details. My previous project, we had, I don't think we had any pages of details. I had one little foundation footer type detail, that was about it. And the project turned out fine, but there was a lot of head scratching, a lot of delays and things like that. So that's one thing. Integrated design team. I'm really envious of these guys. They have a great team. They wear all the hats. They make all the decisions. They disagree, but they don't fight, and they get along. And the end product is fantastic. I don't have a team because I only build something every couple of years, and they wouldn't wait around for me to bring them back into the room. So I always have to go out and try and find people that understand this stuff. And it's hard because there aren't a lot of builders that know how to do this. There aren't a lot of architects that know how to do this. And when anything new, you make people very uncomfortable when you talk about this new strange stuff, and they get prices just go up, because they need that margin of error, that warm fuzzy feeling that if they do screw it up, they'll still make some money. Construction, you need to get everybody to buy in. You need the team, and they all have to buy into the process. If you don't, it can end badly. I've worked with a lot of people in a lot of different capacities, and almost every project, even though they're high performance projects, the architect wants to build a great home. The passive house consultant wants to build a passive house. The homeowner doesn't want to spend as much money as it might cost. Everybody's got a conflicting agenda. And so it's really important, I think, to be successful, to have everybody understand and buy in at the same time in the beginning before you break ground. It doesn't guarantee success, but boy, it can make it a whole lot less painful. It's amazing the number of buildings I've looked at where the subcontractors aren't up to speed, and they don't really care, and they come in and do a crappy job, and they don't understand the detailing that's required, and construction delays, costs go up, and it's messy. It's messy. So 100% buy-in, if possible, is the best way to go. And then finally on the modeling, because Bronwyn asked me to mention this, modeling is just software. And the basic adage of software is garbage in, garbage out. And that's the first thing. So if you have a modeler, they have to know what they're doing. You have to also understand that modeling for compliance with California Energy Code is way different than modeling for passive house performance. California Energy Code is great, best in the country, but I wouldn't call it at all comprehensive. And that's maybe a criticism, but it's still darn good compared to everything else. If you do passive house planning package or passive house modeling correctly and accurately, it does predict performance properly. But it's not easy. Okay, it does take practice and it takes time, and if you actually want to hire a passive house consultant to do modeling for you, it's not going to be inexpensive. It doesn't have to be hugely expensive, but it's not going to be a couple $100. You can go on the internet and find a Total 24 consultant that'll do a Total 24 for $100. At least that's the initial price. Okay. And then there's add-ons and things like that. But still, you can get in and out of there for $400 or $500 for any kind of reasonable building. Passive house requires more work because it's harder. There's more training involved. There's much, much more detail than required for California Energy Code. A huge amount of detail. And it can be painful to learn, but the end result is just, once you nail it, boy, it's great. It's great to see.
I would reiterate, it's a steep learning curve, but once you're up the learning curve, it becomes easier and easier. It's like anything new that you're learning. So great, thanks, Steve.
Sure.
So I'm going to mix it up for our second and to last question that I throw at you, and then I'm going to open up to the audience. And I'll start with Alan. What aspect of the zero net energy design do you now find the most exciting and interesting? Do you want to? We've heard the cautionary tale, a little bit of the horror of the learning curve and the moisture issues, but
I'm
really.
still scared.
It's a healthy fear.
Yeah, 30,000 construction defect lawsuits filed in California every year. Billions of dollars. So I'm still scared.
For conventional buildings as well as net zero,
Yeah,
right?
that's right. Well, I still learn every day, and I think there's a tendency for things to get too complicated. Mechanical systems, any kind of building assembly detail, etc. So part of the thing that we do every project is we try to make the process, we try to make the process simpler. So our production, our costs go down, or it takes less labor. And we just try to make the assemblies, we try to make the materials work better. And and materials are constantly changing. Sometimes we try new materials, and things don't work. They look good on paper. There's a lot of things that look good on paper. They look good in the glossies, right? But I remember one was this is a good example of kind of what we run into. There's a product called a zip panel from a company called Huber that's an absolutely phenomenal building materials company. We use a lot of their products still, but there's a zip panel is one where they took a sheathing panel and they applied an elastomeric surface to it. And the idea being, okay, we're integrating a weather barrier with a sheathing panel. Okay, so it ought to be faster and less expensive to do it. Okay, so he said, well, that's too good not to try. So we tried it on a project, and we discovered two things. One, the supply chain for that material was so poor out in our area that it was sort of academic. We really couldn't, it took us 2 weeks to get the load, and the load arrived sort of half destroyed from transport. So immediately, okay, that's not going to work. I had plywood out there in 3 hours. And we also realized that when we detailed buildings in California, there is so much hardware on the surface, exterior surface of these buildings. There's straps everywhere, okay, because we live in a zone that shakes. So air sealing for us, we learned from hard experience, and we've tried it all. We've tried sheet, we've tried liquid applied, and we've settled on one particular technique through this learning process, and that's a peel and stick membrane. Okay, why? Because we can put up all the panels and all the straps and go through all the process, the construction process, easily, effectively, without any variation, and then we simply wrap the building with this. It's simple, doesn't take a whole lot of doesn't take rocket science or practice and so forth. So,
Name of product?
well, it doesn't matter. There are lots of peel and stick products. There are manufacturers like Grace and Henry and so forth. There are lots of them. We happen to use one now. Recently, we've been using a Henry product called Blue Skin. Yeah, Blue Skin. But there are several that are similar. But that's just an example of why we keep learning all the time, because new products arrive and new techniques arrive. And we're constantly driving toward a process and materials, assemblies that go together easily and simply and that are durable. So I'd say that we keep learning, and that's interesting and exciting, and I think somebody wanted me to talk about monitoring. The other thing we constantly learn is by measuring what we do. You can't manage it or understand it unless you measure it, and my God, is that ever true. So we first started almost 10 years ago again. We measured the first project. We did it with the Department of Energy. I said, well, let's get the pros in to measure this one. So we got a lot of great data with that, and now we use a monitoring system. Someone wanted to know there's several. The one that we particularly use, we think it's cost effective and works. There are more new ones coming on the market all the time. But it's a product company called Sage. But basically it's just one that you put sensors around each of your brand circuits, and you aggregate them. It has a gateway for your Wi-Fi network, and it sends the data up to the cloud. And then there's software that allows you to do analytics on it. But if you don't measure it, you can't understand all these energy loads and what the impact of things are. So we have a pretty good sense of energy loads and hot water. We use heat pump water heaters and different things. So when you do new things, you're constantly surprised by that. And how much energy you use on mechanical systems, like ventilation systems. And we measure, static pressures and all sorts of things. So if you have to measure it or you don't understand it, period. So we constantly are learning more and more about data. So I would just say, my final thing, an example of this, one that just surprised me, and that's why it's so exciting to learn all the time, because we think we understand things, but in reality, the more you measure and the more you do it, things sort of, your understanding gets flipped. So there's a concept of night ventilation, cooling, right? And especially in California, it's a climate zone where it's 15 degrees Fahrenheit cooler at night. So if you use a fan at night, you can open windows, but the most unreliable thing are people. Machines are much more reliable. They don't open windows because they're work late at night and so on and so forth. But anyway, if you use a fan at night, call it a whole house fan or whatnot, you can use this cool air and bring it in and the idea. And we did all sorts of modeling, and we installed systems and we measured them. And on paper, the coefficients of performance, the energy efficiency ratios, which is off the charts, just so phenomenally great. And we did all this, and the Department of Energy monitored it all and verified that, oh my God, the energy efficiency ratios are great, and so on and so forth. But in the end, after analysis, including costs and all this, source energy factors and so forth, we learned from hard data that is actually more efficient. It's more efficient to use a heat pump to cool in the middle of a summer day than it is to use a super high performance ECM motor driven night ventilation exotic system at night. Because the source energy factors are different. And in today's world, the energy you use in the middle of the day in the summer is all 100% renewable, comes directly from a solar panel. And it's getting better and better all the time. And the energy you use at night, when you shift the load to the nighttime, is all base load, and the source energy factors are a 3-to-1 multiplier, so you're demanding 3 times more energy than is actually being consumed by your fan. And if you do that math, using a heat pump during the day is vastly more effective, and it costs less money, and so on and so forth. Don't have time for the details. But the only way we learn that is by a whole lot of measuring and a whole lot of analytics, and in the end, it's completely counterintuitive, but that's the reality.
So, back to me being an African American, right? Remember that. Not what you would expect on the face of it. So let's go to Steve. Sorry, it was a joke that you guys might have missed in the beginning. So Steve, your most rewarding, what are you finding the most exciting?
2 things, I'll be quick. I work with a lot of first-time passive house builders, and they come to that first knuckle-biting blower door test. And this is always before the insulation comes in and the drywall that you're bare framing, but everything's roughed in, so in theory, all the holes are punched in the skin and everything's sealed up nicely. And I love it when I go in and we do the test, and if they actually pass the first time, it's amazing. That doesn't happen that often, but usually they're close, and we spend a couple of hours looking for air leaks, and we find them, and then they pass. And they're like, oh my God, this is amazing. It's like the heavens open up and the light comes down, and the builders are they're thrilled. I love that part, okay. Second part I love is when I go to a house that's already been done properly by, let's say, an experienced passive house builder, or just a darn good builder or something, like one of Alan and Bronwyn's houses. And I go in there to test it at the end. I don't even do intermediate blower door tests for these guys. I don't have to. I go in when the house is done. We do the blower door test, and it always passes extremely well. And the ventilation works perfectly, and the heat pump works great, and the ducts don't leak at all. And It's great. And it's like taking a little vacation. I just had to take some equipment and we set it up and we
Yeah,
tested
we even
stuff.
have time to go out for lunch, right?
Yeah, and we like hang out and stuff. Yeah. You know, but I still get good numbers. See, I love that too. That's a great. These are both great days when those things happen.
I paid him to say that.
There are other builders that do that too. Yes, there's a couple of us. Yes.
David, if you'll give us your upside to all this.
Right. Well, I'd have to say it's happy clients. And this past week, got a call from a client who said, you know, it's 114 outside. This is up in Sonoma County. And I'm staring at my thermostat, and it says 76 inside. And those are the sorts of moments that just make my day, because all of that work we did in the front end of understanding, you know, the building science and the thermodynamics pays off when there's comfort in the house. And then we meant to mention earlier, we use a tool called Sapphira, which is a plug-in with SketchUp, and it does very early schematic modeling. And what we'll do when we're using this tool is we'll turn off the cooling, because we usually don't have cooling anyways, and we'll turn off the heating, and we'll see, is this building going to be reasonably comfortable under those most extreme conditions? And that comes to a concept we call passive survivability, which was alluded to earlier. The power goes out. Are you going to be able to live reasonably comfortably, or at least survive in any climate condition? The second thing is, and I'm sure the others would agree with me, we're part of a movement, and we are addressing climate change proactively. I also serve as the director of the California Straw Building Association. I'm the chair of a task force in the Embodied Carbon Network on renewable materials. We're all working to create a new future that allows us to survive comfortably and live well on this planet. And that's what I enjoy most.
Yes.
Fabulous. What a great end to that section. Now I'm going to open it up to the audience. We've got 5 minutes left, so we don't have a huge amount of time, but I know people have been itching to ask you some questions. So let's start with you. We'll go to Judith and we'll come over here, but let's start.
Well, it won't be a 5-minute answer, but I'll pose the question. With net energy zero buildings, really I think where that's going in the long run, and a few of you alluded to that, was low carbon. So do you see a time when either the spec change, or is that also part of your thinking? And what goes with that, of course, is that retrofits are far less carbon intensive than new, but everybody's excited about the new. So just quick thoughts on some of those things.
So the question was about retrofits versus new and the carbon intensity of that. So I'll throw it out, whoever wants to take that one.
I'll just quickly say that colleagues of ours in the Embodied Carbon Network did a study, and versus building new, they looked at a building retrofit. This was in an office building in San Francisco, 70% reduction in the carbon footprint over new construction. So as someone alluded to earlier, if you have a home with reasonably good bones, there is a lot of activity, building activity, material intensity that went into creating that. We've seen examples, our office has done examples that show that a retrofit can be beautiful to live in and have a lower energy as well as carbon footprint.
Well, I just would say, yeah, that zero carbon is something that's clearly top of the list, right? And the way that the state's policies are progressing is focusing on electrification, both in the building sector and in the transportation sector, right? It's the direct consumption of fossil fuels, either for transportation or thermal energy uses in buildings, and that's heating water and space heating. Okay, so all of our projects now are all electric, because the equipment to do that now well and cost effectively is there. Heat pumps are phenomenal pieces of equipment, particularly in most climate zones in the U.S. now, actually, but particularly in California climate zones. So, I think the battery technology is moving very rapidly. The deployment's moving rapidly. Grid improvements are rapidly. Seasonal storage, there's all kinds of work being done there. So I think the energy storage sector, from what I see, it's just going bananas. And so with renewables, with energy storage, and electrification from a design perspective, it's the promised land, if you will. And I won't speak to retrofits versus new. I mean, that's very situational. I'm actually, most of our work is our tear down buildings. We do single family, but because these buildings are past their useful lives, the foundations are useless, everything. So, we recycle materials and so on and so forth. But to me, the question more is, I'm more concerned about new construction and changing new construction practices, because every year there's, 1.5 million new buildings every single year. So I think it's more important to change the building practices for new construction than it is, because the existing building stock isn't going anywhere. So they're both huge problems, and there's more existing building stock than new, but from a priority perspective, they're both important.
Just two quick comments. One is retrofits are harder, so there's a barrier there, undeniable. Second thing is carbon footprint isn't just about energy. It can be about materials, it can be about consumption, it can be about all those things. And we're pretty weak in that area right now, I think, and there's room for improvement. I'm not saying it'll solve the problem totally, but it can help get us there.
Great. Judith, back.
So my question is about materials. David mentioned a cork exterior insulation, and Alan was talking about zip panels. I find that certification is a difficult thing. I was looking for zip panels that just got ICC number for having insulation as part of the panel.
Right.
And then, as you said, they're almost impossible to get out here. And because I had the ICC number, the contractor had no choice. He couldn't substitute anything for it. He was stuck with this stuff from New York or Massachusetts or wherever. Where do you get cork insulation that's got an ICC number? I gotta get permits for this.
I've seen it on 3 projects, but I don't know about the number.
Yeah, Thermocork is available from the Northwest. I'm forgetting the name of the company, but
Small Planet Supply.
Thank you. There's also an organization in New York City, 475, and they're looking to take the passive house performance to more natural building materials, lower carbon, as I said earlier, mostly plants, but trying to find materials that are less intensive. We did a quick calculation on a long span truss in a building, and the steel version of the truss had 12 times the embodied carbon of the wood version of that truss. We ended up with a hybrid, which was still 60% less carbon. So paying attention and budgeting these things, is the way to, as Alan's been saying, you gotta measure it or you don't know. Even recycled steel, yeah, it takes a lot of energy.
Yeah, to recycle and resmelt it. I'm going to jump to Pat rather than have everybody on.
A quick comment about the cork. We have a passive house right in Santa Cruz where the actual exterior surface of the entire building is cork.
You can use it.
And both those companies that David mentioned are actually owned by passive house fans who have really been instrumental in starting up the Passive House Northwest group and the New York Passive House group. So all of these people, I can tell you, are at the Passive House conferences and at the expos. This stuff is very integral to what the whole Passive House community is doing, because materials also equal energy.
I'll just make a comment about materials again. I reiterate what I said in my first comment. I keep it simple. I use off-the-shelf materials almost 99% of the time. Most of them American-made that I can get at a building supply. And we achieve, net zero energy plus passive house. We do it all the time. You don't need exotic materials, okay, to achieve these high-performance building standards. Okay, we don't need exotic prefab, this and that. We stick frame. We use plywood. We use, cellulose or fiberglass cavity insulation, etc. We happen to use mineral wool on the outside of our assemblies. I know the embodied energy is higher, but it's fireproof. It's completely breathable. It's available. It's a miracle material, and it's easy to get.
And it's not petroleum.
Right? And it's
Yep.
not petroleum. It's fluffy rocks. So again, you gotta keep this simple.
The other thing you may need to do is push your suppliers. Bronwyn mentioned earlier, 3 years ago when I was trying to get mineral wool rigid exterior insulation, I couldn't get it. I spent 3 days calling around California, everywhere, and it shipped up from LA. A little expensive, but it was worth it. Now you can go to any major lumber supplier and get it. There's things change, yeah, but you might have to push a little bit. It's okay.
Right. One quick question back here, and then I'll go to you, sir. But
I raised my hand.
Okay, go.
Very
Yeah.
earlier.
Okay, go.
I'm a homeowner. Like a material is AE job, architect engineering job. But I'm more interested, you mentioned design build for so many times. Right now, to me, design build I understand is 2 stages. First stage is you find architect, engineer, have a good partnership with contractor. You just sell directly. Second stage is 2 stages. You find an architect, engineer, write the performance specs. Then we open bid, outside group, design architect grouping to get this job. So in the California, for residential housing, which more feasible? Just go direct deal or you go to open bid?
I think that's a really complicated question, so it's really
Yeah, I won't
just...
spend too much time on that, but it's, the cultural practice is design, bid, build. Okay, it's designed in one silo, there's architects, right? And it's bid, okay, amongst several potential contractors, right? And then you select and you build one. My experience, I don't do that. That's a disaster. That's a race to the bottom. You're going to try the low bid person. And that's a historical thing having to do with public works contracts and so on and so forth. But if you want to do that, that's fine. The problem is in high performance building is you must, to be successful, you must integrate the activities of the architect. It doesn't have to all be in one company, but the architect, okay, with the builder, okay, because you must value engineer and integrate the building process with the design, and the builder, experienced builder, and the mechanical design part of it as well. You have to, hammer on the architects. Okay, where do my ducts go? Where does my mechanical equipment go? Etc. So you must integrate that process, however you do it.
So when you mentioned value engineer,
I'm going to...
is the AE architect engineer, they involve value engineer?
Absolutely.
Okay, I give you my background.
Yeah, I know, sir. I'm going to cut you off, sir, because I'm sorry. Let's have this question. We can have it afterwards. Yeah, but we're out of time, sir. And and we're coming up at the end of this session, and I can see people are getting anxious. Sir, if you'd like to ask your question, the panelists will be here for a few more minutes. We are out of time, unfortunately. I wanted to just do a quick overview. I have the slide on the screen of our conference that's coming up. Lots more opportunity to learn more. We've really just skimmed the surface today. This is a long journey, and you've heard from our experts. We're all still learning. Every project is new opportunity to learn new products, new systems, and fail better or actually work better. So I hope we have left you with some valuable information.
Is there still time to sign up for the workshops?
And the workshop at LBNL, the workshops, if you sign up today, we will get you in. We have to have a security clearance for those. The other workshops, you can sign up until whenever. And then I wanted to just also close by pointing out I brought a whole bunch of books that I have found incredibly useful resources. I will put a resource document together and ask the city folks to email that to all of you so that you have products, books that I have found particularly helpful, websites. If there are 2 books that I would say are actually fundamental resources that will be really great guides. This is a Details magazine book called Passive House Design. It really covers the fundamentals for both residential and commercial. It's got incredible details in the back. It's a really wonderful book. The website, the company that David mentioned, 475 Design, high performance. The website is 475.com, spelled out, FOUR 75. Has online details for high performance assemblies that you can download for stick frame buildings. They vary, you can vary the thicknesses of the wall assemblies, but they deal with moisture management, flashing, all the hygro thermal transfer through your assemblies. An incredible resource, and they have books, and then they also have products, and they focus primarily on no petroleum products. They do have some petroleum products. There are other places. Small Planet Workshop up in the Northwest has also another plethora of amazing products and information on their sites, and I will, as I say, put together a list for you. But as I say, this is a long ongoing journey, and I really appreciate the opportunity that the City of Palo Alto has given myself and the Passive House California group to share this with you, and I really wish you luck, and go out there and build something really amazing. So thank you very much, everybody. And thank you to the panelists who joined us today.